clarity on what everybody's takeaways from the session. So the poll will be active for everybody right now. So yes, over to you. Let's go.
Sure, sure. So, um, while we get started, first let me give a high-level overview as to what we'll be looking at today. Just a quick introduction about me. I'm Justin Joseph, and I work as a staff AI engineer. I work for Analog Devices at their European Research and Development Center in Ireland, Limerick to be precise. We predominantly focus on building physical AI systems these days. I see that there are a lot of comments flooding in the chat. Is there an echo, by the way? I see a comment on the echo. Is there
Um,
an echo from my
looks
end?
good as of now. Like so there is
Okay, thanks. Perfect. So I predominantly work on physical AI systems. That means reducing the gap between your um, robots and the agentic AI systems. So the robotic systems using agentic AI for thought process to decide what actions to perform, in a way deciding what it is to perform in order to automate the actions in factories or in industries. Is what we are currently working on right now, and we are associating with some organizations like Toyota, BYD, etc., in order to implement our solutions there. All right, let's get started. So in today's session, we will be looking at multiple aspects about an agentic AI system, which is multi-agent in nature, and we'll be discussing about multi-agent orchestration as well. So this is a customer support system that we'll be discussing today. And first, let me just share you a couple of repos in the chat. Oh, wait. Yeah, one moment. Let me just share it in the chat. So the GitHub repo that I've shared with you here is the code base, what we'll be discussing today. And it has an extensive README and everything, which walks you through how to run it on your own machine, how to deploy it on Hugging Face spaces, all of that. Um, and the database which we are referring to is this. Uh, I'm seeing a few suggestions on a lot of echo, dual voice, etc. Um, can you?
Sounds good to me. Actually, let me just
Yes, good to me also, guys. We can hear
Okay.
you clearly.
cross my
Not
code.
sure why the echo comments are coming in, but sounds
And
good.
and yeah, and there is no background sound here. It's just 7:30 a.m. People are hardly waking up. So all right, let's get started. So yeah, so today we'll be focusing more on foundations, and we'll be going over certain core concepts on how to build this system, what the system does, the architecture, the database, the agents, the memory system, and the full life cycle that we have. And day two is more production focused. We deep dive into the observability aspects, how to handle errors, how to scale this, and how to go ahead with real productionization aspects behind the system. So, uh, day one is understanding what we have. Day two is understanding why we have those and what next. All right. Okay. One moment. Yeah. So this is what I just mentioned. So in our project today, we will have concepts from LangGraph. We will have the OpenAI models in the backend, so we don't have to worry about the LLM aspect. And we have the Chinook dataset, which we use using SQLite in order to use the data for grounding purposes. Grounding means we have to ensure that the LLM is a customer service chatbot. So we have to ensure that it speaks only based on the data that it has. It never hallucinates, or it should never hallucinate, and it should always respond to based on the user data, based on the music data, etc., that we have. And the Chinook dataset is a music dataset that we have here. And we'll be using Thread.io for front end. So this is what we'll be discussing today. So we'll discuss what agents do we have, what are the aspects of LangChain that we have inculcated into this, how does our dataset look like, how does our UI look like, all of this. And tomorrow, in day two, we'll be looking at how to orchestrate the solution and the complete deep dive into the code that we have, the observability aspects. So once we have the system in production, what should we be looking at? The scaling aspects and how to productionize this. And by the way, if you have any questions, please mention your questions in the Q&A. We have a TA who is going to respond to your queries, because I know that this is a sizable cohort. We have more than 1,200 participants. So it won't be possible for me to respond to your queries in real time. And we just have less than 3 hours at our disposal. All right. Let's continue. Yep. Okay. So yep. I don't have to cover these slides, right? Well, yeah, let me just skip all of these. And let's have a quick word about the multi-agent customer system that we'll be working with today. So many a times when we work with customer systems, especially customer systems where we have LLMs in the backend, there is always a chance for hallucination. There is always a chance for the LLMs taking control and responding to your questions based on the data that it has already been trained on. But that is not the data that a customer service chatbot should respond to based on. It should be heavily grounded to the data that you are providing it. For example, if it has access to the user data, if it has access to the past transactions, if it has access to the uh, products that the organization is offering, etc. So it should be heavily grounded and no amount of hallucination should be tolerated in that. Now, in our use case is focusing on a customer support system where we use the Chinook dataset, and the Chinook dataset is focusing on uh, music data. So we have different tracks, we have different genres, we have different records, etc. And in this music data, we'll be asking, and we also have multiple customers who are using this. So for each of the customers, pertinent to each of the customers, the past subscriptions, the past purchases, the past interactions, the past preferences, etc., should be known to this agentic system, and the agentic system should respond based on that. So that is the expectation. Now, in case if it is not grounded, or in case the agentic system is not responding based on the data that we have, what happens is the agentic system is going to hallucinate albums. Like for example, there are a lot of albums out there, but this Chinook dataset that we have will not have all of the albums in the world. It will be limited. So it should not hallucinate albums. For example, this is not an example of hallucination, but I can relate to it this way. So in Netflix, the Netflix search is very good. So I type the name of a movie. I start typing the name of a movie. It says that, are you looking for this? It gives me an autocomplete, and I'm surprised. Yeah, I didn't expect that movie to be there. But the search is great. I click on the movie, or I choose the name of the movie that I'm interested in, and then Netflix says, we don't have that. So that is not an example of hallucination, but I just wanted to give you an idea as to how it's going to look like. So if it's a live customer support chatbot, you are going to ask whether it has some particular, for example, if it has Thriller from Michael Jackson. And if this data set, or if the organization does not have it, and if your LLM would definitely know it, but the LLM has to be grounded, and the LLM should say that it does not have access to it. And the LLM should not respond to it in an encouraging way because it does not have the product, or our customer, or our chatbot, or our customer base, or our product base does not have that product in the first place. So, which is why grounding is essential. And similarly, it should not hallucinate any aspects about the past purchases, invoices, etc. Now, our project focuses on using structured SQL access to real data. And we'll be using multi-agent routing so that the right agent handles the right type of query. The user can ask many types of queries. And if we have different agents under the hood, which handles the different kinds of queries. And it also verifies the identity of the user, the account data is pulled, and it also ensures that the account data is not given to everybody and only to the user who has been authenticated. And from an authentication perspective, we don't currently, this is just a project. So we don't have many guardrails for authentication. We just use customer ID for that temporarily. You can add additional authentication guardrails, like, for example, password, OTP, etc., which is not a part of this project as of now. All right. Now, so yeah, one moment. Okay. So before we get started with what we'll cover today, the scenario that we'll handle today is we are working with a digital music store, something like your own version of Spotify or your own version of iTunes. And we have a customer service chatbot for that. Now, the customer can browse the catalog, ask about the different genres, artists, albums, songs, etc. And this agent that we have is going to query the SQL database or the SQLite database to be precise and returns the exact data that the user has asked for. And no room for guessing, no room for training data, but pure actual real-time data that the SQLite database exhibits. Now, the second thing is to verify the identity using a customer ID, email, phone number, or anything, any combination of this. And the system is going to check against the database before letting the user anywhere near the user specific data. Once the user is verified, the user can access their account, past invoices, any purchased tracks, any billing information, uh, any other kind of assigned support representative, etc. Now, the fourth part is the remembrance of the system. That means if the user has said in the past that they prefer rock music, these preferences are to be stored so that in future, when the conversation comes up, it should know the preference of the user and then handle the user accordingly. So these are the aspects that we have. All right. One moment. Yeah. So we have different sections that we have to cover today. Before that, a quick recap once again about the four aspects that I discussed earlier. And the first aspect is to browse the catalog. Browse the catalog. The second aspect was to verify the identity of the user. The third aspect is to access account data, like the past invoices, etc. And the fourth aspect, like we said, what was it? The memory of the system. That means the preferences, the usage history, etc. Now, these are the four aspects that our chatbot is capable of doing. But taking a few steps back, I'm pretty sure that I'm pretty sure that all of you in the chat will not be knowing what an agent means because I have been repeating the word agent, agent, agent. So the idea is actually simple. You know what an LLM is, right? LLM is simply text in, text out. So you pass, it's like your GPT 5.0. It's like your Claude Opus. It's like your Claude Sonnet. All of these are examples of LLMs where you pass in a text, it provides text as an output. So that is large language model. Now you take the large language model and you wrap it around certain other tools and other mechanisms, making it an agentic system. So why do we do this? It's because you have many large language models out there, starting from OpenAI's GPT 5.0 or whatever. And these LLMs are capable of understanding text, reasoning very well, uh, understanding the context, and all of this. Now, the challenge here is that how do we use it for our use case? In order to use it for our use case, we have to attach it to our database. We have to attach it with our tools, for instance. All of this helping provide a better context or better information to the large language model so that this LLM can respond more effectively. So the idea of agents is simply wrapping your LLMs with many other aspects, including tools, databases, etc., making it capable to be your own system. Like, for example, the customer service chatbot that we are going to build today. So that is the difference between an agent and a large language model. So you can consider, in very, very simple words, you can consider an agentic system to be a wrapper around an LLM. Now, an extension of this is that the chat GPT that you use, the application, I'm talking about the application. I'm not talking about the GPT 5.0 or the underlying language models. The chat GPT is an agentic system. It is not a language model. Why? Because if you ask a question, like for example, what is the weather in Limerick today? It is going to fetch information from weather.com and it is going to give you back information saying that this is the weather at your location today. Please keep in mind that the model underneath, the large language model underneath, was never trained on this data. because I'm asking a question about right now. And it was never trained on this data because the model that is there underneath would be probably 3 or 6 months old. But it is able to access the real-time information by triggering calls to tools, databases, tools like, for example, Google search, or like, for example, weather.com's API, where it can just give the location as well as the date to the weather.com's API, and weather.com's API is going to give back the weather to it. So on and so forth. So the LLM takes the query, understands what the expectation is, looks at the tools or the databases and everything that it has access to, then decides what tool to be triggered, and then takes the query, structures the query in such a format that the API or the tool can be triggered. So the tool would expect an input in a specific format. So that formatting is done by the LLM. LLM triggers the tool gives back the answer, and the LLM takes that answer and then gives it back to the user in a very conversational way. So LLM is the brain, and the agentic system means looks like a human body, where the brain is the LLM, and the hands and the legs and all of the other parts are the different tools, databases, etc. So this is the high level idea about what an agentic system is or what an agent is. So today we'll be discussing about a multi-agent system. All right. So let's look at the different. Yeah, core concepts. The core concepts and before we look into the code, we need to have a understanding of our. Yes, please.
I think we lost you for like 10 seconds, so you might have to repeat your last sentence.
Okay. Did I finish what agents were?
Yes, right after you finish
Okay.
that, we started it.
Okay. The analogy that I was saying is that if you're considering an agentic system to be a human body, the brain is the LLM, and the hands, legs, etc. are the different tools, databases, etc. that the agentic system has access to. Now, coming to describe whatever we'll cover today, the first section would be the core concepts and definitions. And the idea is that before we start looking into any code, we need to build a shared vocabulary. We'll start talking about certain aspects like checkpointers, interrupt nodes, etc. And we'll be discussing what that is because I'll be using those terms again and again as the discussion progresses. Now, that is the first part that we'll take a look at. And the second part, okay, so that is about the core concepts and definitions. So let's get started with that. I think we'll go it step by step. The second part would be the system architecture overview. I'll discuss the architectural diagram. We'll discuss the database layer. We'll discuss the different agents that we have, as well as the different tools that the agents has access to. We'll discuss how the identity verification is done and how the memory system works. The idea of memory system is that it needs to keep a track of what the user preferences are. Like I mentioned earlier, like if the user prefers rock music, the memory system should remember that this is the preference of the user. Now, we also have extensive prompt engineering because detailed prompts, whenever we deal with LLMs, we need to have detailed prompts to guide the LLMs in a refined manner. And this also helps in anti-hallucination. Or in other words, the LLMs shouldn't just provide an output as to what they already know, but it should be extremely grounded to the data that we provide it. Now, we'll also discuss the flow of execution, and then finally, we'll just discuss interview preps or what could be possible interview questions coming out of this. All right. So we discussed the problem statement earlier, and yeah. All right. So one moment, give me a moment, please. Let me just take a look at the. All right, one moment. Yeah. So the problem statement is that we have a structured SQL access, which is a Chinook SQLite database that we have. And that is to ensure that we are providing enough context to the LLM. And that mitigates the issue that there is no access to real business data, but this one has access to the real database underneath so that it can behave like an actual customer support agent. And we have a multi-agent routing as well because we have different agents focusing on different aspects with different capabilities with access to different tools. And we have an identity verification because only the users, so I shouldn't be getting information about you and vice versa. So I should only be provided information about myself. That is why we have the identity verification. And then the persistent memory. Persistent memory was what I was referring to as the preferences earlier. And the grounded answers. So the project that we have builds bridges the gap that traditional chatbots have, like for example, the lack of personalization, the lack of memory, the lack of identity verification, the chances of hallucination, the limitation in having multi-turn conversations. Multi-turn conversations means uh, smooth, free-flowing conversation, and also proper access to business data. All right. So, in a digital music store, before we go into how our system is built, in a digital music store, the customer should be able to browse the catalog, verify the identity, access the account data, and get the personalized help. All of this, which we discussed a few slides back. All right. So browsing the catalog, verifying the customer's identity, accessing the past invoices and everything, and also getting personalized help as to what the preference of the user is, etc. Now, starting with the section 1 that we have as to what an agentic system is or what an AI agent is. So, like I told, it's a wrapper built on top of an LLM, making making it capable of autonomous decisions and autonomous executions. That is what an agentic system is about. These days, at least some of you might have heard about OpenClaw and stuff like that, right? Or some of you might have used your Google Anti-Gravity or Claude Code, etc. So the idea is that all of these are agentic systems where they have the capability to even interact with laptop or in your system, whereby, for instance, you can set up your Python environments, you can set up whole project code bases, you can get it running in your local and all of it end to end without you having to implement all of this. So these days, vibe coding is getting, I mean, people are reducing vibe coding and people are going into agentic coding. So if you're somebody in the software engineering space, you would have already had a flavor of it. So I also do that regularly. So these days, organizations do not ask you to build from scratch, but they ask you to prompt agentic IDEs in order to develop your code and then make iterative changes on it by using your idea of system design, by using your idea of optimization. So that is what organizations are expecting out of you these days, rather than coding from scratch. Your interviews might involve coding from scratch because they need someone with uh, skills and capacity in order to get this done, rather than somebody who doesn't know anything, someone who just prompts. So you need the domain knowledge, you need the tech knowledge in order to prompt these agentic systems properly so that they can come up with whatever you were anticipating or even better. All right. So you have the LLM, you have the different tools, you have the different databases that it has access to, you have the different um, MCP servers. I'm not going into that. Different aspects that the LLM has possible access to, enabling it the capability of autonomous decision making because it doesn't need to hallucinate anymore. It has access to the different tools that it can trigger whenever it is required, and then it can fetch the responses from the tools. And based on that, it can give you the comprehensive execution of whatever you were requiring. So there is also something called a React agent. We will be discussing that as well. So the React means not your friend end React, but rather this is an agentic terminology. It's called the reasoning plus action. The idea of reasoning plus action is very simple. So earlier I took the example of you asking the question to ChatGPT as to what is the weather in Bangalore, for instance. And ChatGPT or the LLM takes a look at the question and understands that this person is looking for weather. So this is the reasoning that's happening. Understanding that this person is looking for weather. And the location that the person is interested in is Bangalore. And the date that the person is interested in is today, the 18th of April. And what the agentic system does is that it first reasons. And then by reasoning, it understood this. And then reasoning is not done yet. It takes a look at the tools that it has access to. And one of the tools that it has access to is the weather.com API. And the description of that API says that it is capable of fetching the weather for you. And the LLM, on seeing that, understands that that is the API that has to be triggered. Now, the LLM already understood the query from the user. So it takes a look at the API. What is the API expecting? The API is expecting the location as well as the date. So what it does is it converts the user's input to a JSON format or whatever format that the API is expecting. And then it triggers the tool or the API. And the first part that we discussed until now is the reasoning part. The moment it triggers the tool, it enters the action mode. The action mode is triggering the tool, and the tool is going to return back the weather, and the action is complete. Now, based on the response from the weather API, it decides to reason again because now it has access to the weather information. So, is that sufficient information to provide a response to the user, or should I be continuing the reasoning? So, or should I be triggering another action? So, it understands that it doesn't need to trigger another action because it has all the information that the user requires. And based on the output from the weather API, it is going to take the output and then structure it nicely in a sentence or a visual format and give it back to the user. So, this is reasoning plus action. So, so there are multiple ways on how to prompt an agentic system or how to create an agentic system, and React is one of the methods or one of the frameworks using which we create an agentic system. All right. So that is the reasoning, action, and observing the outcome of the action. I would call it reasoning again. That's it. Okay. All right. Now, yeah, I was talking about the React pattern, right? So this is the same thing, the reasoning plus the action. So the um, if given a query, for example, the user asks a particular query like what rock albums do we have? And based on this question, the LLM receives the question. The LLM thinks, okay, in order to mention the rock albums that we have, I have access to the SQLite database. So I need to search the music catalog that I have. Now, I'll use a particular function, like for example, the get songs by genre, because the genre was mentioned by the user as rock. So let me use this particular function, get songs by genre, in order to get the response for the user. And under this function, we had a SQL query execution buried underneath this function or inside this function. And that SQL query is executed. And for that SQL query, the genre was important, and the LLM provided that from the user's query that the SQL query is now executed and the action is now complete. Now, once the action is complete, the outcome of the action is a JSON with 10 rock songs across the different artists in the genre rock. Now, based on the outcome, it is going to perform further reasoning that it has enough data. Now I have access to enough data. Let me reformat this JSON into a particular format that the user would appreciate. Probably it will break it down into a tabular format, or it would convert it into a numerical bullets or whatever and give it back to the user. So this is just an extension of the same weather example that I referred to earlier. But this is pertinent. This use case is pertinent, or this example is pertinent to our customer service chatbot. All right. I hope the React pattern or the reasoning and action pattern is clear with everyone. Now, going to one of the most important components today, LangGraph. So, LangGraph is the framework that we'll be using in order to build the agentic system. There are many frameworks available out there, and we are just using LangGraph. And LangChain, you might have heard of, is a much more simpler variant where it does not use a graph system or a graph method in order to create the agentic system. So you can actually create agents using LangChain as well, but it is going to be a much more simpler agent, especially when you're dealing with multi-agent systems. LangGraph is better than LangChain, and especially for production grade systems, organizations, and people who productionize agentic systems prefer LangGraph over LangChain. There are a lot of other alternatives, like for example, Crew AI, and all of these alternatives are also covered in the IK course, by the way, because I had taken a look into the course and I understood what exactly they are covering. There are a lot of different aspects that the course covers, by the way. If you're interested in it, you can hit up interview kickstart. All right, now let's continue. So LangGraph. So I did tell that LangGraph is a framework that we use to build this multi-agent or the multi-state AI workflows. And this uses the concept of directed graphs. So the workflows would be like a graph where you have nodes connected using edges, which which is how it manages the workflows. Now we'll discuss all of this, what node is, what edges is, etc. Now, to start with line graph, we need to first talk about state graph. The idea of state graph is that, see, the state graph is the graph from which every node reads. And this is the graph to which every node writes. So the reading and writing happens using a shared typed dictionary. So you can think of this as a shared whiteboard that is out there. And this whiteboard is what is being used by all of the system. So your complete system can read and write from this whiteboard. So consider your system like a team of engineers and you have a whiteboard. So everybody is contributing to this whiteboard and everybody is going to read information from this whiteboard. So that is your state graph. Now you have the node. The node is your Python function that receives the current state. And after receiving the current state, it does some work. And the work can be something like calling an LLM, running a query, etc. And then it returns the updated state fields. So the node is in charge of executing something, doing something. And after doing whatever it is supposed to do, it is going to return some updated values of states. Now, you have the edges. In order to connect between nodes, or in order for two nodes to communicate with each other, you have the edges. And the edges is like a directed connection between nodes. That is why we refer to it as a directed graph. So node 1 can communicate with node 2 if it is directed, if that particular direction is active. Now, yeah, let's continue. So we were talking about edges, right? So edges are the directed connections between the nodes that we have. And these edges can be conditional. Like for example, the edges look at the current state and decides what node to go into next. So edges handle the direction or how the flow should be managed. Now, next is what you have as a checkpointer. The idea of checkpointer is that, see, your state of the graph would change after every node is executed. And this is what enables a multi-turn conversation. Like your system can remember what was said earlier, and it also takes a note of what changed right now. And this is what the checkpointer is responsible for. And it saves the state of the graph after every node is triggered. So the checkpointer acts as an intermediate checkpoint, just like the name suggests, as to what keeping a trace as to what happened when the node was executed. Now, there is interrupt. The idea of interrupt is that an interrupt, like the name suggests, it pauses the graph execution completely. And this is what ensures that we wait for the human input and then it resumes the process. So, interrupt, for example, the user is trying to access their past invoices. But before accessing the past invoice, we have to ensure that the user enters their credentials. And while the user enters their credentials, this whole instance interrupts and waits until the user provides their details. So that is an example of interrupt. So identity verification. So we wait until the user provides the information. Now, then finally, the store. The store is the persistent key value storage per user. And we use the store in order to save music preferences across different sessions for the same user. So consider it like a memory store. So this is the idea of line graph. So to give you a quick recap as to what the different components of a line graph is. All right. So we have the state graph, which is like the whiteboard or the shared memory. Now, instead of passing your variables between the different functions, your state graph is going to rely on a strictly defined type dict or the typed dictionary. And this dictionary acts as the single source of truth for the entire workflow. And when the graph is executed, every node reads from this exact state graph or from this exact same state and writes back to it. And the state is like the shared memory for all the nodes. Now, the nodes are like your workers. So they are standard Python functions and they do the heavy lifting, like receiving the current state, executing the logic, like, for example, triggering the LLM, parsing the document, executing external API call, all of this. and it returns a dictionary consisting only the deltas or only the updates. So the nodes return the updates that are to be made, and the line graph merges these updates with the state graph. Now, the edge dictates how the data flow happens, or how the execution happens. So your individual edges, they are static in nature. So, for example, your individual edges always goes from extract data to format data node. Now, this is an example of normal edges. Then there is a category called conditional edges. Conditional edges are what makes the system agentic. Like, for example, it is like a routing function uh, to evaluate what the current state is. And then based on that, it decides what the next step should be. For example, when attempting to trigger a tool, for some reason, the tool failed. And if it is a normal edge, it is going to throw an error and it is going to stop there. But if it is a conditional edge, it is going to, in the instance of a failure, it is going to route back to the LLM saying there was an error and this error was an input error. That means the input that the LLM created to trigger the tool had a flaw, and the LLM corrects it. Now the tool is triggered again, and this time it works. So this is an example of a conditional edge. Now the checkpointer, and the checkpointer is responsible for taking a snapshot of the state graph before oh, snapshot of the state graph after every node finishes the execution. So consider this as a thread level persistence. So the idea is that, see, in case the pipeline crashes mid execution, for example, a pod goes down or something like that, the checkpointer allows us to resume the workflow from the exact node where it failed rather than starting over everything again. So the checkpointer focuses on remembering the steps leading up to the current moment so that it can go back if required. So it is like taking snapshots of the state graph after every node finishes the execution. And your store finally is the global memory or the long-term memory. So the checkpointer is going to remember the steps of a single workflow run. The store is a persistent key value database spanning across different sessions, across different threads, so that if you have any updation in your preferences, that is stored in the store. All right. And then the interrupt was there, right? So interrupt enables this fully autonomous agents to wait for human inputs wherever necessary. Okay. So I hope the concept of line graph is clear. If you have any questions, please ask in the Q&A. The TA will be happy to answer them. All right. And if you still have questions, we would have a question answering session somewhere towards the end. Okay. Now, all right. Yeah. The key terms you must know. So, okay. So I'll be just going through the terms superficially so that you can understand at least what I'm referring to when I reuse these terms in the conversations as we go ahead. So tool. Tool is a Python function that we use, which consists of a tool decorator that the LLM can decide to call whenever required. So consider it like a Python function. So in the Google Gemini or the ChatGPT scenario earlier, weather API can be a tool, and it could be in a Python function. And your LLM can call it whenever necessary. And how does the LLM know what the tool is capable of? You will provide textual descriptions as to what each tool is capable about, so that the LLM can understand what the capacity of each or what the capability of each tool is, so that it can decide whether to trigger that or not. Now, the supervisor. In our multi-agent system, we are going to follow a certain architecture called the supervisor agent. So that means there is a supervisor agent that decides which of the sub agents are to be triggered. So the supervisor agent is going to take in any query that comes in, and it decides how the flow or which sub agents are to be triggered and when. So the supervisor can be considered uh, as a supervisor. So whatever takes in the input and whatever calls the other sub agents, that is your supervisor. Now, the React agent we already mentioned, the reasoning plus action, that is a framework or that is a strategy of how to create an agent. So alternate between reasoning as well as actions. So reasoning is your LLM and actions are your tool calls. Then state. Like I mentioned earlier, State is a shared type dictionary that all the graph nodes read and write to. So it is like a single source of truth for the entire conversation across the sessions, across the users. Now, grounding. Grounding is ensuring that your agent is going to answer only based on the data that is in your database. So it should not answer based on any other knowledge. It should not answer based on Wikipedia knowledge that it was trained on. It should not answer based on any other music databases or data sets that it was trained on when, for example, if you're using OpenAI's LLMs, we have to ensure that when OpenAI trained them, they would have trained it on music data as well. So we want to ensure that your model, your LLM does not uh, respond to based on that data. So that is grounding. Now you have interrupt. I already mentioned that pauses the execution and waits for the human input before continuing. That's a part of LangGraph. Now the in-memory store. In-memory store is if you want to persist the data like preferences across the session, we'll be using in-memory store from LangGraph in order to store the persisting values. Now, what else? Yeah, memory saver. So memory saver is your LangGraph's checkpointer. Checkpointer means storing the graph state within a single session. That is, oh, sorry. Okay, storing the graph state within a single session. That is your checkpointer, and that is what memory saver is about. Then you have the parameterized SQL. Parameterized SQL refers to SQL queries using the param placeholder. So instead of string concatenation, SQL queries using the param placeholder is known as parameterized SQL. And the idea is that it prevents any SQL injection that could be a threat to your whole system. Now, the thread ID. The thread ID is a unique identifier that identifies a user's session because we are expecting this agentic system to be run parallelly by multiple users, multiple sessions, etc. So the thread ID distinguishes the different sessions. That's all. All right. Let's take a look into the orchestration versus single agent. So this is an architectural discussion where we discuss why multiple agents, why not one single big agent. So there are many systems that work fine with just one agent. It doesn't mean that we have to use multi-agent everywhere. In this particular use case, we are using multi-agent, and we'll just mention the advantages of multi-agent systems over your single agent systems. So your single agent systems means one LLM handles everything. Now, the prompt is going to grow big and the tools might conflict with each other. Your debugging is going to be a nightmare in that case. Or when you have to add additional capabilities to your system, it is going to struggle, or it is going to require extensive rework through the whole thing. So, which is why if you have modularized multi-agent system where you have specialized agents handling different concerns depending on their domain or depending on their capability, along with access to specific tools isolated per agent, then it is more modularized. Any scaling requirement, any change requirement, any debugging issue can be handled much better in a multi-agent system. And the chances of conflicts are also minimal because they're modularized in nature. Now, each agent can have a focused system prompt. Like, for example, there could be an agent for retrieving the records or retrieving the records that the organization has provided. So if that is one agent, then you can give a detailed prompt saying that you can consider yourself as somebody in the store who picks the correct music catalog and provides it based on the requirement. So that is an example of a system prompt. System prompt means the prompts that we are providing under the hood for an agentic system to ensure that the different agents behave the way that we expect. So that is an example of system prompt. It is free flowing text, but we are providing it. The end user is not going to see it, but we are providing it for each agent, ensuring that the agent is behaving the way that we expect it to. So in a multi-agent system, each agent can have a focused system prompt. Otherwise, if it is a single agent, then you will have one agent that does everything. That means you have a very big system prompt saying that in this case you have to do this, in this case you have to do this. So you will have many conflicts as well. And there is a higher chance for your LLM to not behave the way that it is expected to, or your agentic system to not behave the way that it is expected to if you use a very big single agent system with a huge system prompt. Now, this also, like I said earlier, this also means that each agent's behavior is traceable and we can identify the issue by tracing it back, which we'll discuss tomorrow as well. Now, all right, so considering all of this, and if you want to add any new capability, you can create a new subgraph node, which is your new agent. So your agent in the agentic system is treated as a subgraph node from the LangChain's graph perspective. So it is just adding a new subgraph node when you want a new agent. That's it. So adding capabilities also is much easier for a multi-agent system. All right. Now, let's take a look at the system architecture. So that completes section 1. This was an introduction as to what the different capabilities of our system are, what are the different terminologies that we would be discussing, as well as why did we go for a multi-agent system. Okay, so let's go to the system architecture overview. After we looked at the vocabulary, now we are looking at the full picture. And this is a high-level system architecture. And this high-level system architecture has 5 layers. And every single user request is going through all the 5 layers. And the first layer is the user interface. And the user interface means whatever the user is interacting with. So it is using Grad.io, by the way. This uses Grad.io. And Grad.io is a Python package that helps us spin up quick applications. And for example, this is how our application is going to look like. And this is just around 10-20 lines of code at most. And we did not have to create the front end using React or anything. And Grad.io really helps us spin up very quick, front ends in such a way that you can describe as to what you want. If you want a place for the user to input, you can ask that. If you want a chatbot like interface, you can also use preloaded interface from Grad.io, so on and so forth. So the location of this is the source folder within which you have the UI, within which you have the app.py. So in the code base that I shared with you, I can share it with you once again because I see that many people have joined a bit later. So here is the code base. Yep. So in the code base, when you go to source, when you go to UI, within that there is the app.py. This is where you have information about. Yeah. This is where you have the different blocks of Grad.io set, and you have the HTML of Grad.io defined. So the interesting thing is Grad.io really helps us build applications, build UI, even if you are not a front-end engineer, in very easily. That's the whole idea about the user interface. Now, the next part is the user interface is where the user has the chat, the session management, the status display, etc. Then the next part is the verification layer. So the verification layer is the verify_info node in the LangGraph. Graph. The idea is simple. It verifies the customer ID. It verifies the email, the phone number, whatever that you're providing, in order to ensure that the user has access, or the session has access to the user information. Now, the memory layer. The memory layer has 2 nodes. The first node is load memory. The load memory is going to read the existing preferences from the store before we process the request. Now, the create memory is the second one. That is used to set new preferences after we have responded. So before responding, load memory. After the response, you have the create memory if the memory has to be updated based on the user's preferences. So inherently, in load memory is like the read, create memory is like the write for the preferences. So next one is a supervisor or the router, which is the LLM router that we discussed earlier. So it understands the user's intent or expectation and decides something like, is this question a music catalog question? Or is this question an invoice question? Depending on that, it routes accordingly to the corresponding correct subagent. So your supervisor is a parent agent that receives any input, and the supervisor decides what subagent to be triggered. So something like a music agent, invoice agent, etc. So we have multiple agents. We'll discuss that as well. Now, after the supervisor is triggered, the supervisor triggers the correct sub-agent. Now, the sub-agents, like for example, you have the music catalog React agent, which consists of 5 tools that it can trigger. And then you also have the invoice agent, which is also a React agent, which consists of 4 tools. So the invoice information, this hits the Chinook SQLite database and fetches information from them depending on the requirement. So the sub agents are there, the parent agent is there. So the parent agent decides, or the supervisor agent, it decides what sub agent is to be triggered depending on the user's intent. All right. Now, this is a high level system architecture. Now going into line graphs execution flow. And this shows the state transitions as well. So the idea is that, see, from a graph perspective, how does the flow happen? Starting, you have the verify info. This verify info node. So by the way, each of these are nodes. The verify info node checks if there is already a verified customer ID in the state. That means in the current session, is there already a verified customer ID? If there is a verified customer ID from a previous state in the same conversation, then it decides to pass through. That means it says that, okay, I verified, so let's continue. If it is not verified, that means if there is no customer ID verified yet, then it tries to extract and verify an identifier from the user's input. So that means it is going to ask the user, like provide the user ID or email or phone number or whatever is required to verify. Now, if the verification fails, what happens is it goes to the human input and the human's input is triggered again and using the interrupt node this time. So that means for some reason, if it does not have verification or if the verification fails, the human input is triggered. And while the human input is triggered, it goes into an interrupt state. So that means it's going to wait for the human's input. Now, this is where the customer provides the credentials, and once the credentials are input and everything is successful, the graph resumes back to the verify info, and the verify info goes back to the load memory, and after loading the memory, it comes back to the supervisor. Now, once the memory is loaded, after verification, the supervisor is triggered. The supervisor, once again, is your parent agent that decides which sub-agent is to be triggered. Now, your supervisor can take 3 possible paths. One is your music catalog sub-agent. And this music catalog sub-agent is for music related questions. Or it can also go to invoice info sub-agent. Invoice info sub-agent is for billing questions. What was my past invoice? What was the most expensive purchase I made? All of this. Now, or it can also go to create memory. If any off-topic questions which are not relevant to music catalog or invoice information, it will go to create memory so that it can add that as a part of the memory. Like for example, a user mentions that they are interested in rock music. Then the create memory will be triggered and that preference would be added to the memory so that it can be reused later. So this is a high level Landgraph overview or Landgraph execution flow to showcase that state transitions. So now you might have understood that the scope is not huge. So we are actually talking about a system with limited scope, and that itself has its own complexity within it. So we did not go for a very complex system because of the limitation in time, and also because we have folks from different, different capacities. From people who doesn't know what agents are, from people who don't know what LLMs are, from people who don't know how agentic systems work, all the way to people who might have implemented agentic systems at scale. So we are trying to achieve a middle ground here, catering to everyone in the best way possible. All right. Okay, so the tech stack. We actually took a look at the tech stack earlier, but this is a detailed tech stack of what we are going into. So starting with LangGraph. So for orchestration purposes, across the different nodes, across the different edges, across the different states, checkpointing, all using LangGraph. And in the backend, we need an LLM, like I mentioned earlier. So the LLM that we have is OpenAI's LLM. So we'll be using GPT-4 or Mini for this purpose. Or you can use any OpenAI compatible API or any OpenAI compatible LLM that you have. But to run this, you will require the OpenAI API key. And if you want the OpenAI API key, you will have to register with OpenAI and you will have to get a key for yourself. So you can just go to platform.openai.com and you can just log into or create an account, and you won't be able to see the key here, don't worry. And you can just click a new secret key and you can create a key. And you can also add probably $5 or something so that you can use the key to your requirement, how much ever you want. And it is, once it's going to hit your limit, it is not going to prevent it is going to prevent you from using it anymore, because it's not a free usage. And in case you want something like a free usage, you can go one step ahead. You can have your own open source LLMs running in your own system, and then you can utilize that. And if you're interested in open source LLMs, I'm going a bit tangential. If you're interested in open source LLMs, you can try going into Olama. And Olama, one moment. Yeah. Olama has a full list of open source models that you can download any model of your choice depending on the number of parameters of your preference. And then you can run them or execute them on your own hardware using the Python package Olama. Just letting you know in case you do not want to use OpenAI's LLMs. But here we are using OpenAI's LLMs because otherwise integrating our own LLM would add a bit more complexity in it. All right. So what were we discussing? We were discussing the LangChain. So the LangChain OpenAI. Okay. So yeah, that is the LLM aspect. Now the supervisor. In order for supervisor, we are using LangGraph supervisor with this. So the LangGraph supervisor package is the routing layer that acts as the supervisor, triggering the subagents. Now, the database. For database purposes, we are using SQLite, and the SQLite in memory is being used via SQL Alchemy 2.0. So this is what we use for the database. Then for data validation purpose, the idea of data validation is that I did tell you that in order to trigger a tool, the LLM understands what the tool is expecting. The LLM creates the input in the format that the tool is expecting and triggers the tool. The tool provides the output in a fixed format. So there should be something that validates all of this, validates the structure, validates the key values and all of it before the tool is triggered, and also validates the output response before the response is passed to the LLM. And that is where data validation comes in. And we are using Pydantic for data validation. So it verifies this LLM output structure and also the data types in order to ensure that nothing breaks in between because of data inconsistency. Now, for front-end purposes, I already mentioned that we are using Gradio for this, for the chat interface, with streaming purposes. And for testing purposes, we are using PyTest. We have 28 tests that are written covering the different tools, the database, etc., etc. And for yeah, that is Gradeo. And all right, so what is we talked about the SQLite in-memory SQLite. We did talk about that, and we are using the in-memory SQLite because we want a very minimal uh, latency in the reading and writing operations. So all the data rests on the server when the server is restarted or started. So in production systems, you will be swapping this in-memory system into something like PostgreSQL or SQLite file or something like that, because storing all of this in memory or storing all of this on the server is not going to be feasible for a productionized system. So that is a change that you should be making if you want to take it to production. For now, we are using SQLite in memory because we want blazing fast read and write. Okay. So we'll talk about changing this to PostgreSQL in day 2, by the way. Okay. Now, we crossed like 1 hour. Okay. Cool. So the database layer. So let's go through the database and let's go through how the agents query the database. So the Chinook database is what we have. And the Chinook database, consider it like a sample database of a digital music store, like your mini iTunes. Now, this consists of 3,500 plus tracks, 347 albums, 275 artists, so on and so forth. Now, the entire database is loaded into memory, or it is loaded into the in-memory SQLite at the startup. And during the querying, you don't require explicit input-output operations because you have it completely in the memory or in the server during the process. Now, this makes it very fast and this makes the responses very quick. Now, each SQL query runs against your RAM, not against your disk. So since you don't have any input-output operations on the disk, it makes it very fast. Whenever you have disk in the picture, or whenever you have hard disk read and write operations in the picture, it is going to be slower. So we just wanted to speed it up, so we use this. But for production systems, this won't be feasible. All right. Yeah. So this is the Chinook schema diagram. And in the Chinook schema diagram, the idea is that you have the customer information. Yeah, you have the customer information, and the customer information is connected with the invoice as well, because for each customer you can have multiple invoices. And I'm not going into each of the concepts, each of the aspects here, because customer has customer ID, first name, last name, email, phone number, etc. I'm not going into all of them due to the interest of time. And because that is also not an agentic concept as such, and this is self-explanatory, by the way. So each customer is connected to multiple invoice, and one customer can, okay. So the customer also has, what do you say, connection with an employee. Like, for example, each customer has an assigned support representative, and that connection is what this is. Now, the invoice contains invoice. Oh, wait, why is it going? Yeah, the invoice contains invoice line. The idea is that each line item refers to a specific track. So the track belongs to an album. So you can see it. The invoice contains invoice line. Invoice line references track. The track contains, or track belongs to, sorry, track belongs to an album. Now, and an album belongs to an artist, or album is by an artist. Now, the tracks that you have here are categorized by the genres. So rock or pop, etc. Now, the track is also encoded as a media type. So you can see here, for our tools that we have, if you have to traverse the music queries, you will have to go to track, whichever track that you are preferring. And from the track, you might have to go to the album. From the track, you might have to go to the album and also to the artist. And this is to query any music related data or music related information. And on the other hand, if you have to query something invoice related, you will have to go to the invoice. And from the invoice, you will have to go to the invoice line. And from the invoice line, you may have to go to the track and the artist. So your invoice can be based on certain multiple tracks, multiple artists, etc. So you might have to take that flow: invoice line, track, album, artist, in order for invoice queries. For music queries, you can directly go to the track and then go to the album and genre. Now, if you have to go for any support representative queries, then you can just uh, refer to these two, the customer and the employee. That would be sufficient. So once you have the schema, whatever joins are there inside your SQL queries, you will get a better understanding of that once you get an idea of the schema. So the three aspects are, the multiple aspects are not three. You have the employee, you have the customer, the invoice line, and you have the track, the album, and the artist, as well as the genre and the media type. Okay. The database.py is where your core functions are there. So I'm not going into everything in complete detail because we have a limitation in time as well. So what I can do is I can superficially explain this. So yeah, so you have three core functions that power the complete database interaction. So you have the run query safe function. And this run query safe, what happens here is that inside this, you have a SQL injection mitigation or a SQL injection preference. So the idea is that we use SQL Alchemy's text function with parameter bindings, with param bindings here that prevents any SQL injection. So the idea is that the user input should never be concatenated into the SQL string. And the database driver handles any escaping. And a malicious user content or a malicious user cannot inject SQL. So if you know SQL injection, this is to prevent any SQL injection happening to your system. And then consider it like a guardrail or a function to safeguard any malicious attempt in order to get into your system. Now, the JSON output, all the results are given back as JSON. Now, this is what the LLM receives. The LLM triggers a tool. The tool provides an output in the format of a JSON, and that is what the LLM receives. And this is structured and this is predictable. And just that you have to validate that the particular JSON is provided in the format that you expect, and it consists of everything that you were expecting. That's all. And yeah, so that is the JSON output. And then the error isolation. So we just discussed this error isolation. The idea of error isolation is that on a tool level, your errors are captured. So that means a bad query or a bad input never crashes the entire agent. And that means if the tool is triggered with an incorrect JSON schema for some reason, then your entire agent should not crash. Rather, your agent should get an error message that the input was erroneous, and then the agent or the LLM has a chance to rectify the input, and then the LLM can provide a rectified input, once again triggering the tool. So error isolation refers to on a tool level, your errors are caught and logged so that it doesn't crash the entire agentic system. Now, the singleton engine. The idea of a singleton engine is that we are not reloading the database on every single query. Your database is resting in your RAM or in your memory, so that you don't have to reload the database every single time, or you don't have to perform read or write operations. And that is what we are referring to as the singleton engine. So I just wanted to mention these functions that are used in database.py, and you will be able to find the database.py in the here, one moment. Yeah, in the database.py here. So these are the four functions that we discussed just now. So the run query safe, then wait one moment. The verify the database, then what else? Yeah, the text functionality here, and the JSON output in the specific format that we were expecting, all of them. See, the JSON output, all of them. So I just wanted to touch base on the different aspects of the database.py that we have here. Now, what else were we looking at? Singleton engine, we just discussed that. Okay, one moment. There was also one more function, right? Yeah. So for example, this normalize font function. So this is a small function that we have where the font numbers can be formatted in a lot of different ways, right? So you yourself know that your font number can be written in different ways. Yeah, especially if you're in US, those folks use brackets and all to represent their font numbers. You might have the plus symbol in the phone numbers. You might have the 0091, etc. if you're an Indian number, or you might just start your Indian number without the international prefix, etc. There are different ways to represent a phone number. Now, without normalizing it, the problem is that they would fail to match the database record. So the normalized font function strips all the non-digit characters and keeping the leading plus if it is present, and formats the map to the same normalized form that it is expecting in the schema. So this is just a simple function in the database.py ensuring that everything is consistent. That's all. I just wanted to touch base on this as well. That's it. Now, taking a look at how the database is loaded when we start. So first, it looks for a local file. So it looks for a cached local file, which is there in the cache or not. Now, the Chinook SQLite.sql is in the project root. And if it is cached from a previous run, yes, that will be picked. Now, if it is not there for some reason, what happens is it is going to be downloaded from the GitHub repository, and there is a 60-second timeout for the download. Now, I already showed you the database here, right? This is the official GitHub repo for the database, and this is the actual database in full detail. If you want to take a look at it, you can just Google for the Chinook database, and this is going to land you here. Now, coming back, and if the data is not there, it is going to be downloaded, and after downloading, it is going to be cached locally, so that when you start it up again, it is going to skip the database fetching. Now, the SQL script is executed into an in-memory SQLite connection using the execute script. So like I discussed earlier, everything is in the memory. There is no read and write operation happening from a hard disk. Now, we wrap this connection using a static pool SQL Alchemy engine. So what happens here is we want to make it thread safe. That means when you have multiple concurrent requests coming into the system, it shouldn't throw a conflict. And that is why we have to make it thread safe. And in order to make it thread safe, we are using the static pool SQL Alchemy engine for this purpose. Otherwise, when you have multiple users running it parallelly, you will face issues with parallel accesses across different threads. Now, this is a very high level overview as to how the database is loaded at startup. Okay. So I did mention that for production systems, we won't be using the same, but rather we'll be using something like SQLite or PostgreSQL for production, which we'll deal in day two. Okay, so, all right. Then the next section, which we are going into is the agents and the tools deep dive. By the way, one moment. Moin, should we take a break or something? When is the break scheduled for?
The break
What time is the
after
break
this
scheduled for?
session, like the break is between the section 4 and section 5.
Okay,
Once
perfect.
done
So
with
after this section, let's have a break. Yeah, thank you. That's perfect. So this is section 4, going into agents and tools deep dive. Okay. So I did mention about the supervisor, which is your LLM router. So giving you a high level overview in this section, we'll be going through the supervisor, we'll be going through the sub agents, we'll be going through the different tools that it has access to, and we'll also go through the React pattern that we have. React is the reasoning plus action, which we discussed at the start of the session. Now, coming to the supervisor. So the supervisor is the first agent in the flow after the memory is loaded. So the memory loading is complete, then the user's query is going to trigger the supervisor. Now, the supervisor is not a full React agent. It does not call individual tools. And this is purely a router that routes the query to the corresponding subagent. So supervisor doesn't have access to tools. In this architecture, the supervisor doesn't have access to tools. The supervisor is responsible simply to route it to the correct subagent. That's it. So the supervisor reads the user's message, and it reads the supervisor prompt. So one moment. Yeah. Here, this is the supervisor prompt. So I just wanted to highlight it. So the supervisor prompt is like the system prompt that tells the supervisor what to do, or it gives the set of instructions in a textual format to the supervisor as to what to do. So if you remember what system prompt is, even your ChatGPT, Gemini, all of them have system prompt, mentioning explicitly how it should behave, how it should not behave, how it should handle conversations, etc. So system prompt can be considered as a set of text or a set of prompt given by the creator or the developer as to how the different agents or how the different systems should behave. because the LLMs are capable of understanding the text. So the system prompt will also be injected into the LLM along with the user's query so that the user query can be answered by using system prompt as a reference or system prompt as a set of instructions. So we call it the supervisor prompt because this system prompt is for the supervisor agent. Now, it reads the user's message, it reads the supervisor prompt, and then makes a decision. Which sub-agent should be triggered? That is the only decision that the supervisor triggers. So, which sub-agent is to be triggered? And that is the decision that the supervisor agent makes. Perfect. Now, we have a routing table or we have a decision table. The idea is that if the question is about a music or catalog, then we are going to trigger the music catalog subagent. And the music catalog subagent is going to fetch the songs, albums, artists, genres, etc. that the user has asked for. Now, the responsibility of the supervisor is to understand that this query is about a music or catalog, and based on that, it is going to trigger the corresponding subagent. Now, the next one, invoice or billing query. If it's a query on invoice or billing, it should trigger the invoice info subagent. And then if it is a mix of both, like for example, invoice as well as music as well as billing, then it is going to trigger the invoice first. One moment. Yeah. In such an instance, it is going to trigger the invoice first and then the music. So first the invoice agent, then the music agent. The ordering is deliberate because the billing context should be established first. Now, there is an off-topic query. It is not about music. It is not about invoice. It is not about a combination of both. In such a scenario, like for example, somebody asks weather information, general knowledge, or anything outside our domain, then the supervisor agent simply is going to respond with a rejection. So why we are doing this is because we want to ensure that our LLM's tokens are not burnt for no reason if an input is not pertinent with our use case. Like for example, I think I read this somewhere. I forgot the name of the organization. There was an organization that created a customer service chatbot, and people started using it as an LLM because the LLMs that they use, ChatGPT, Gemini, etc., they are free versions and they are extremely limited. And this customer service chatbot has an LLM in the backend, and people started using it as an LLM because it was not handling off-topic queries properly. So any question that you ask, you can ask question about physics, chemistry, math, and it is going to answer you. And that is going to burn your tokens. You don't want that. That is going to increase the usage of your LLMs. And since we are using OpenAI LLM, we are going to be charged based on our usage. So we want to ensure that any off-topic query is shut down. And that is the direct rejection that we were talking about. Now, after we have discussed the routing decision table, let's take a look at the supervisor prompt once again. And the supervisor prompt contains the exact information as to never add information which is not in the subagent responses, indirectly asking it to ensure that it should not add any information from its training data, from its learning, which is not there, in any of the sub-agent responses, because the sub-agents are going to do something, going to fetch you the responses. Explicitly asking the supervisor not to add anything more than what the sub-agents brought back to you. Now, it is this set of instructions is if it is an off-topic question, respond directly with rejection. And you can also add, if you want, you can also add as to how the rejection should be happening. Now, if it's a mixed query, then it should go for invoice information subagent first and then music catalog subagent second. So this is the set of instructions. And then why we did not specify that if it is a music question, it should call the music catalog subagent. If it's an invoice question, it should call the invoice information subagent is because whenever you define subagents or tools, you will be defining what these subagents or tools are capable of doing so that you don't have to repeat that again in the system prompt. So you just have to mention the capability of the tools or the subagents or whatever is as text so that the supervisor agent also has access to it so that it knows when to trigger what agent or what tool. And any other scenarios, you can mention it in detail in the supervisor prompt. And also, if you have other instructions, like for example, this is how it should behave, this is how it should respond, this is the kind of terminology or vocabulary that it should use, all of these instructions can be given in the system prompt or the supervisor prompt. All right. Now, coming to the first subagent, the music catalog subagent. The music catalog subagent is hand built. That means we built it. So we manually created a React loop as a state graph with two nodes. So the React loop I already discussed. We already discussed what a state graph is. And this consists of two nodes. The nodes that we have is the music assistant node and the music tool node. The idea of the music assistant node is that it has it's an LLM with tools bound to it. And the music tools node is a tool node that executes whenever or that executes whichever tool the LLM chooses. So the music tool node is responsible for executing the tool. The music assistant tool is an LLM with tools bound to it. And the uh, sorry, music assistant node and music tools node. So music assistant node is an LLM with tools. And the idea of this is that this is the part which reasons. And this is the part that decides whether to call a tool or to produce an answer. That is the music assistant. So call a tool or produce an answer. Now, that is music assistant. The music tool node is that whenever a tool is decided to be triggered, the music tool node is what is to be triggering the tool. Now, there is an edge or a connection between them. And the connection between them is that if the LLM's response contains tool calls, then go to music tool node. Now, if not, go to end. So this is the React loop. So music assistant is there, which is the LLM with the bound tools. And if the LLM's response has tool calls, then the music tool music tool node will be called, and then it will come to an end. If it does not have a tool call, then it is not going to trigger the music tool node. That's it. Now, okay, so I just mentioned the React loop as to how it works and the edge between them. Yeah. Okay. And once the tool node has finished execution, by the way, once the tool node has finished the execution of the tool, we go back to the music assistant because the LLM reads the tool's results and then it decides again as to whether any other tool is to be called. So this is your reasoning plus action that I was referring to. So music assistant calls the tool node, music tool node. And once the tool node is triggered, then the response is brought back. Response is brought back to the music assistant. Then the music assistant might decide to call another tool if required. This is your reasoning followed by action, followed by the response of the action to come back to the reasoning module. The reasoning starts again. So within the music catalog subagent, we were talking about tools. What tools? So these are the 5 music catalog tools that we have. The first one is the get the albums by artist. So we pass in the information, we pass in the name of an artist, and it is going to trigger the get albums by artist tool. So the idea is that it simply searches for the albums based on the artist name. Then the next one is get tracks by artists. The previous one was get the albums. This is the get tracks. So once again, it takes the artist's name and then it is going to provide you the count of the number of tracks of the artist plus up to 20 tracks with full details created by the artist. So it is not going to give you the complete comprehensive list of artists, but up to 20 tracks of the artists with full details corresponding to it. And the next one is get the songs by genre, and you pass the genre corresponding to it, and it's going to give you the songs corresponding to the genre. One moment, I think I had triggered something like that here. Yeah, what are the rock songs that you have? So this triggered the songs by genre tool that I had mentioned before, and the genre was rock. By the way, reformatting this in such a way that the tool is called with what do you say, with the parameter as rock. That thing is done by the LLM. I hope you're clear with that now. So how the tool is called, the input to the tool is structured by the LLM. So here the input to the call is it's just a function, right? So here the input to the call is just the genre. So the whatever we are passing in is just a genre. So it is going to trigger the get songs by genre function. And whatever the parameter is given by the LLM. And the LLM understands the user's input and then fetches this part and then creates that into the parameter and triggers the function. And here you can see that these are the list of the songs that were in the catalog. By the way, this is not a comprehensive list once again. Okay. So here what happens is get songs by genre. It uses a raw number CTE. Oh, wait, where is sorry. It uses a raw number CTE to return one song per artist, and it is a deterministic. It is a set of deterministic results every time. So the idea is if you are asking for a specific artist, then it is going to fetch you one song per artist for a genre. If you are asking for genre along with artist, but if you just ask for a specific genre, it is going to give you a number of results. Now, this is a check for songs. The idea of check for songs is pass a song title and it is going to check the songs based on the song title that we have used or we are asking for. So up to 10 matches will be provided for it. And then you have the get track details given a track ID. Track ID, not the name of the song. Given a track ID, all details for the specific track ID will be fetched and given back to you. All right. Now, you can modify this, you can add your own tools, you can modify the existing tools, you can do whatever you want. Just that these tools were designed so that you can make comprehensive usage of the data that you have and you can produce the output in the required format whenever required. So that's it. So why we use tools is that why don't you let the LLM do everything? Why do we even use tools? Because the LLM cannot directly interact with the table and fetch the correct data without mistakes. So the LLM is always prone to some error, some hallucination issues. So if you can have such tools that can help fetching information from the database in a better manner, then that would be the best. Because granting LLM complete access to the database and asking it to do all the operations from it, the chances of an error is much higher. And many times the LLM might not have access to the database in the first place. That's another thing. All right. So
Thanks.
one moment. Okay, so yeah, should we do we have some more time to finish this this part? Because I wanted to cover a few more things if time permits.
Close to phone.
Okay. Cool. 1 minute. Database PY.
So I think
Yeah, the thing is, I was just looking for the invoice part. Oh, that's after this. Okay, let's have it after the break then. No worries. Yeah.
Sure, Jason. But then very insightful session, like very interesting what are like taking people through over here. And I was looking at the participants also. I think we have more than 90% who started the session still in here. That's like testament to the fact that people are getting a lot back from the session. So I think as things stand, I'll just pull up my screen instead. Let me let my screen visible. Yep. So we were able to look at system architecture overview, the database layer, as well as we were going through the agents and tool deep dive. But just to take a break, I think you've been talking nonstop for over an hour at this point in time. Drink some water. I'll just take people, and that goes to the participants also, like while you're distilling the information, keep yourself hydrated. And now, after the small break that we're having right now, we'll be talking in depth about identity verification and then go ahead to like the request lifecycle. And in the end, at the last part of the session, Justin would also be able to take all of you through how you would deal the interview questions in today's landscape with the kind of agentic skills that we're talking about. And while you're here, so the maximum utilization of your time. So this is what we keep telling our participants every time we have an AI Launchpad. The thing is, you have to stick with the sessions over the 2 days. So that might actually make sense to you. It comes out as a complete package. That also means I saw some questions on the chat. The certificate at the end, if you're able to attend across and like do the needful things. And also one more thing is when you're like engaging in the Q&A. So this is what usually happens, and I saw that happening a bit today as well. So whenever somebody's putting a question in Q&A, feel free to cross answer, create that rapport. It always compounds and helps you. And now I'm also going to play a video from our founder so that this is a very important message that has actually helped a lot of AI engineers out there as well. And you'll also get to hear it from someone like Ryan himself. So go ahead and playing this. In case my audio is not like coming through, let me know.
AI is no longer the future. It is here, it is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many, many, many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers. In many cases, are $300,000 to $400,000 more than their peers simply because they have the AI skill set. The challenge, though, is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years, and I've already worked with over 25,000 working professionals from all domains in tech, software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom who come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals. And so they bring their frontier lived experience to every single class. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one size fits all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers. And we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up level to building a fabulous AI career.
Nobody else like Ryan to explain why we do what we do at IK. Hope this is insightful to everybody. And then very few slides from my side here. So basically, one thing we've been noticing, especially in the recent thing, is this literally a first stage of AI denial, where I can't do AI is something that a lot of people has moved on from right there. And I think from our interactions with the customers or like prospective learners, what I always realize is that I can't do A because there is too much out there is the biggest denial stage right now, where the maximum number of people in the Indian landscape who are towards the tech is because of the lack of structure out there. And I can't do A because my job is unique and so safe. And then this last where people who feel like they have a lot of experience at this point in their domains, and breaking into AI right now might be a step down in their career. One thing that I can comment with a lot of confidence is any of the four stages of the AI denial you are at, you are actually living in a bubble, and it's high time that you look outside the bubble. I guess you guys being in today's session is the biggest testament to the fact that you guys are actually people who are looking out for things and trying to learn and do, which is essentially the kind of people who Interview Kickstart wants to associate with. The reason being, when you look at how someone who is actually able to leverage this inflection point that's like the AI in the tech careers is here. How it actually works is it can actually be built into two parts, where the augmentation and transformation. So LLMs and copilots is where everybody is at, and if you're able to reach a stage where you're able to build those agents, like build on top of all those existing models, and even build literally deep models. So at the end of the day, what we want to do is, if you're someone who is at the augmentation level, we want to equip you with the right skills, the right tool stacks, as well as the right structure so that you can reach where you want to be in this curve that is. So now if you look at this, what happens if you're able to create this transformation on your skill set as well as career? So basically, there's a lot of new targets out, new roles that you can target that's like out there. There's the AI SWE, AI product managers, AI TPMs. And on top of this, if you look at how the jobs have been surging, we have been seeing like by an average around 175% increase in the kind of jobs where AI is required and is now mentioned in the JD itself. So this is a bread and butter. So we see this at a very close lens, and this is what all the insights in the market is pointing towards. So now if you look at how can Interview Kickstart actually enable you in this transformation of yours, there's three flagship programs that we design, and each of this, within this three, I'll go deeper into each one of them very quickly. But before that, the idea I would actually borrow from Ryan when he was saying the core principle of Interview Kickstart is we want to meet the engineers where they are at, like whatever you are doing right now, wherever your skill set is. So we actually build our offerings in such a way that we can actually cover the maximum percentage of people, so that we can give you guys the best personalized experience possible out there. So our offerings, if you look at this from a very nutshell manner, are threefold at this point in time. So Agentic AI Accelerator and Interview Lab. This is in fact done in partnership with an enterprise partner, like PwC India is a partner on this program. So this program essentially lets you go to build an enterprise grade multi-agent system in a span of 12 weeks. So there is 12 weeks of getting your AI portfolio, AI skills up to speed, up to like enterprise level. And on top of that, you also get to prep on interviews, how to deal with those questions, where you're able to justify it, where you're able to answer those systems questions correctly. So you spend that time, essentially, it would be super worthwhile for you, because you come out the other side with an PwC India backed portfolio. Along with that, you come out with skills that are like market relevant, and a tool stack that would literally be being used by the Mang engineers in their company. But the only catch here is, if you're somebody who is like super new to this, does not know Python at all, barely heard about LLMs, it might not be the best course for you, simply because to go from like a zero level to the level where it's like at which the Mang company functions, it's impossible in a short span of time. So we only recommend this program for those people who actually have an intermediate Python knowledge already, or someone who is an engineering leader who actually know his way around coding. Someone like, there'll be no code track on this program. But that's where our transformative Gen AI and agentic AI plus Interview Lab comes into play. So that is more like a complete system. And the best thing about that particular program is that it is actually broken down into 18 different domains. So the 18 domains that you see, if that program actually has a variant for each domain, the projects in this program are essentially built in such a way that you get core domain expertise and are able to answer the questions about why you did what in an interview that you're coming up. So again, this is also a very important, not important, very amazing opportunity if you're looking to upskill in your career. And the best part about this program is also that you get like once you couple this program along with the interview prep, uh, if by 6 months you are not actually able to crack anything, you're not seeing your career go where you actually wanted to, we are so confident that's like a very outlier scenario. We work on a 50% refund thing. So that's how confident we are on our system. And our third offering right now is the flagship ML and interview lab. This is a much longer commitment of 6 months of like learning it from the core, and then another 4 months of interview prep. Here, the idea is that you are someone with very barely any knowledge of the ML industry, but want to pivot your career completely into ML and AI. So that's why the longer commitment as well. And the learning would also be like super great. On the other hand, the structured system essentially lets that very chaotic path for you be like super streamlined and straightforward. Now, how much does this cost? So this is how the financing stands at this point. And now if you see, this is the 50% refund I was talking about earlier. We obviously partner with crazy good partners who actually lets EMIs be like super easy if required. And on top of that, you also become part of the IK alum base, which is at this point around 24,000 strong. And that means a lot of referral. In the last quarter alone, just to throw a stat at you, we sent 200 plus job opportunities to our alums in India of like L6 plus roles. Yeah. And now if you look at the pricing, there might be a first thought, okay, is this information that's actually available out there on the internet? Do I really need to pay this money? But think about it. If you are someone who's a senior engineer out here with, let's say, 8+ years of experience, the kind of opportunity gap you're missing by not having AI on your portfolio, on your skill set right now, this would barely come to 1 or 2 months of that opportunity you're missing. So definitely what we are trying to do here is there's an inflection point going on out there in the market. We're just trying to equip you there so that you ride the wave the exact way you can. With that, I also would like to run a poll. The reason is the way we work on a or rather our sales team works. We want to talk to people who are actually genuinely interested in talking more, taking the career somewhere, right? So the way our team is structured, what we actually do is like a consultative approach, wherein you come to us, you tell us where you are, and we will be able to identify whether there is a match, whether there's some offering of kind which we can actually find synergy with, and then take it forward. So I've run a poll right now, and so if you're able to see the poll, mark whether you would want to be talked to by the person, because once you mark on this, because that actually unlocks a direct pathway to the program advisor. But another pro thing about that is this program advisor would also be able to hook you up with the recording of the session. They'll be able to give you the repo links again if you seem to have missed it. Along with that, they'll also be able to give you like slots of when do we do this next, because we've seen that people always keep asking how do we keep a track, and they can also maybe help you join the community that we operate with. In parallel, once done with this, I'll also put a Calendly link out there so you can directly book time with the program advisors out there. And that brings me to my end of my session. Just before that, I'll just tell you guys one more thing. That's how if you are to associate with IK, we don't leave you midway, just like how we're committed like to enabling your career. So at the end of the day, you have a full package. So if you look at this, we are giving you mock interviews. There's around 15 to 20 mock interviews that we're talking about. Then your resume, your LinkedIn, every way that you can think of to get a step ahead, we would be there with you. So yes, that's my time. And just second thing, I can give it back to you. Yes. Let's go ahead and
Sure. I see that there are a lot of questions. So if you have any questions with respect to what's being covered, please feel free to ask it in the Q&A section. So the TA will be able to support you by providing the responses. I came across one interesting question. So which component is responsible to understand the human text and interpret whether the user's prompt is looking for the genre or album or singer? And that is exactly why we have the LLM. So if you ask me about which component is doing that, if you remember, I had talked about the music assistant node earlier. So within the music catalog subagents LLM, you have the music assistant node, and that music assistant node is responsible for this. So the user might ask something like, do you have anything by Hendrix? Do you have anything by Eminem, etc.? And this arrives at the music agent. The LLM reads this query and looks at the music assistant prompt that it has. The prompt would be something like, okay, look at it and try to understand whether it's a genre or singer or whatever. And based on that, and along with the tools that it has access to, it will combine all of this, and then it'll understand. The LLM understands whether it is the name of a singer, or the name of a genre or an album. So to answer in simple words, the answer is LLM, whatever LLM that you're using. But to accentuate the performance of the LLM, you will be using the system prompt, like the music assistant prompt that you're giving, and also the detailed descriptions of the tools that the LLM has access to, so that it'll understand what the tools are capable of, what the LLM should be doing, what it is expected to do, all of this. So based on that, it will fetch whether it is a genre or whether it's a singer name, etc. So to answer the question in simple words, it is mostly the LLM's pre-training that is making it capable to handle this. All right. And there was also one more question, and that question was about before LangGraph. Before we started talking about LangGraph, what did we cover? So we covered some aspects mentioning the basic expectation out of this multi-agent system. And that basic expectation out of the multi-system, where exactly is that? This one. Oh wait, let me just share the screen. Yeah. So before we started discussing LangGraph, this was what we discussed. So the digital music store that we are attempting to keep. So it should be capable of browsing the catalog. It should be capable of verifying the identity of the user. It should be able to access the account data from which you have the invoices, past transactions, etc. of the user, along with getting personalized help as that of your preferences, your suggestions, etc. So this is the basic expectation out of this, and we also discussed the reasoning plus action framework, so which we have extensively used in our application. Okay, so earlier we had discussed one sub-agent, and what was that? This is invoice extraction, and the other would be extracting information about the genre, singer, or in other words, extracting information about the song or anything related to that. Let's go there, one moment. Here we were here. Music catalog sub-agent. I just forgot the name of that. That's it. So the music catalog sub-agent, we discussed as to how it works, and there we discussed the music assistant, and that is what the LLM inside that is what understands whether it's a genre or a singer or whatever, and it has access to 5 tools as well. And the nodes are written in such a way that you have 2 nodes, and the nodes are connected with the connection as to whether there are tool calls or not. And then we also discussed that it's a reasoning with action framework here. Now, the second sub-agent. So we have the supervisor. The first sub-agent is the music catalog sub-agent. The next sub-agent is going to be the invoice information sub-agent. And coming back to invoice information sub-agent. So once again, it uses React, or the reasoning plus action, create React agent. And this agent is LangGraphs built that handle internally. Now, we pass this to the LLM. We pass the LLM the tools that we have, which is a list of invoice tools, the 4 of them, which we'll discuss soon. Along with that, we'll pass to the LLM the prompt, which is the invoice sub-agent prompt, mentioning how this agent should be behaving, what is the expectation out of this, and all of it. Textual or string in nature. And then the state schema, the check pointer, and as well as the memory store. So all of these will be passed together to the React agent so that it can decide as to what action is to be performed, and it can perform the reasoning followed by the action. That what action is to be performed is the reasoning part. So, right. Okay. So earlier we had done a manual React mechanism. Here we are using the React mechanism directly from the LangChain's pre-built constructor or LangChain's pre-built function create React. React agent. So both of these approaches provide the same identical React behavior. But if you want to encapsulate it, if you want the help of a framework to do it, you can use this function, which is precisely why we implemented both agents in two different ways, even though both of them are React in nature. Okay. All right. So, all right. So coming to the invoice tools, the first invoice tools tool that we have is the get invoices by customer sorted by date. So, like the name suggests, it gets all the invoices, the most recent invoices coming up first. And for this, you have to pass the customer ID. And the next one is get invoice line items sorted by price. Once again, providing the customer ID, where it produces all the purchased tax across all the invoices, sorted by the unit price in the descending format. So the next one is get employee by invoice and customer, where you have the invoice ID and the customer ID. In simple words, find the support representative linked to the specific invoice that was raised by the customer. And the final one is get invoice line items, which takes in the invoice ID and the customer ID. And this gives the full track details for one specific invoice. So these are the functions, pre-built functions pre-built means we built it with respect to the invoice information subagent, where the action triggered can be to call any of these tools. All right. Now, please note that the customer ID here is the required parameter. So customer ID is a required parameter for all of them, all of these functions that you saw here. Now, this customer ID is never extracted from what the user is typing in. The customer ID is injected as a system message. So if you remember, the user authenticates themselves by using the phone number or whatever. Now, this session has a particular user who is verified. Now, you cannot just inject, you should not be capable of saying that, okay, fetch this particular invoice from this customer, because it could be a different customer's invoice. You should never provide access to it. That is why the customer ID is extracted as a system message from the context or from the user that is currently accessing the system or the user that is currently interacting with the chatbot. So customer ID is never about what the user injects, but rather it is like a system message. So this is like a simple security boundary, but very important. All right. Now, coming to the anatomy of a LangChain tool. All of the tools that we discussed, 5 tools for the first subagent, 4 tools for the second subagent, all of these 9 tools follow the same pattern. And that pattern is what we are going to discuss now. Now, one moment. Sorry about that. We had removed some slides in the interest of time. So I was just looking at whether we have time to cover that as well. If yes, it would be good. So yeah, here. So here you can see there is something called the tool decorator. I'll just zoom in. Here you have something called the tool decorator. And the tool decorator is responsible for registering this function as a tool with LangChain. So the LLM sees the name of the function. The LLM sees the description of the function. And the LLM can understand what are the parameters that are required as well. Now, the LLM has access to this only if it is described as or only if it is decorated as a tool. And now the LLM can have access to it. So that is the idea of this tool decorator. Now, this doc string here, this comment here, the triple quotes in Python means comment. This comment or the doc string here refers to the description of the tool. Now, by default, you are not expecting an LLM to read the entire function and understand what it is supposed to do, because each functions are isolated and without the whole context, you might not understand what it is about. And that is where this doc string is going to help the LLM. Also, we can't expect the LLM to be capable of understanding code very well, because LLMs are usually text in, text out. So you need to provide a description of the function. The textual description of the function is what I have highlighted here, which is the tool description. Now, LLM reads this, and then based on this, the LLM decides whether this tool is to be called or not, given a scenario. So the description or when to use the tool or what the tool is capable of is this. Now, what is the parameterized query? So one moment. So here, yeah, you can see that this one here. So, where exactly is that? I'm just searching for something. Oh, yeah. I'm just trying to look for something, whether I can see that here. Okay, ignore it for now. So the idea is that I wanted to show you an example of fuzzy matching. If you remember this pattern that we were talking about earlier, this particular thing that we were talking about earlier, we are talking about fuzzy matching. So if you have something like this, the percentage AC/DC percentage, it simply means that we are trying to match any string containing AC/DC. Now, this is how partial queries work. So if you have something like show me the Beatles albums. Now, the database has the Beatles, but your user asked Beatles. Now, if that is the case, you should attempt to match any string that contains the Beatles. And that is why such a fuzzy match will be used, saying that percentage Beatles percentage, so that the Beatles, anything else with respect to Beatles will also be fetched. So I just wanted to mention that particular uh, pattern or the fuzzy matching part. That's it. Now, the parameterized query. The idea of parameterized query is that, see, we already discussed this pattern, right? So the idea is that the user will never touch the SQL string directly. Every interaction with the SQL is done by an explicit function without the user directly touching it. So if you were confused with it, it's fine. You can ignore it for now because that is not going to make significant changes to the architecture or the understanding of the whole concept. Now, then there is an empty check. The idea of empty check is that if the query is not going to return anything, we want to return a friendly message string saying that, and not an empty list. So the LLM can relay something like no albums are found for this particular genre or this particular artist, etc. That is what we are doing as an exception, not an exception. It's like finally, if we do not have any result coming in, then instead of that, you can give this. Now, then we are also returning the result. In case the result was not empty, we'll be returning that JSON result. So the result is a JSON string, by the way. And we are saying that the run query save function is going to trigger the SQL in the backend, and it is going to fetch the album ID, album title, album name as artist name, and from this album with any other particular requirement. So all of the requirements are mentioned here. And the thing is, here we are going to say that anything that consists of the name of the artist that we are interested in. This is a variable. Artist is a variable, by the way. Anything that consists the name of artist that we are interested in. It could be somewhere in between. It could be the entire name of the artist, whatever. Then that would be fetched. So this is a general idea about the tool that we have created. So it consists of the tool decorator. It consists of the doc string. These are the most important things. Inside this, how you write the tool totally depends on the tool that you're using. But all of our 9 tools in this particular example is focusing on this particular flow or this particular method. And in the end, it returns a JSON. Now, yeah, this is what it is, the anatomy of a LangChain tool. So the LLM reads the tool specification, which is the name of the tool, the doc string, which is the triple, what do you say, double quotes comment, and then the parameters of the function. And then after the LLM reads this, the name is going to tell the LLM what is the function. The doc strings is going to tell the function when to call, is going to tell the LLM when to call the function, what it is capable of. And parameters tell the LLM how to call it or what is to be passed to it. Now, based on that, the LLM decides to call the function or the tool with a particular parameter that we are passing. Now, inside that, it attempts to perform a check and it attempts to perform a pattern binding where the SQL, where the information from the SQL DB is fetched. Now, the results are attempted to be fetched, and if the results are there, then it is formatted into a JSON array, and then it is sent to the LLM. LLM formats it into a text to give it to the customer. And if it is no, it returns no albums found based on what we saw here. This one. If there are no results, then it returns no albums found, and the LLM takes it back to the customer after reformatting it once again. All right. So this is the anatomy of a LangChain tool that we have written here. Okay. Now coming to the next section, which is the identity verification and memory system. We already mentioned about why identity verification is important, why memory is important. So verification grants you access to the sensitive account data, be it your past invoices, be it your preferences, and all of that. Memory makes the system personalized, like it retains the conversation history, it retains the past preferences. All of these things are based on memory. So by the way, when you talk about an agentic system is LLMs plus tools plus databases. I already mentioned all of that. One aspect which I forgot to mention earlier was memory. So do you know that LLMs by default do not have any memory? So if it is a default ChatGPT, not ChatGPT, the GPT-5o. So if you ask a query to GPT-5o, and then you ask a next query or a prompt to GPT-5o, it won't remember the previous conversation because LLMs are stateless. LLMs are stateless. This is very important. And that is why when you build a system around an LLM, you want to have multi-turn conversations back and forth. Back and forth means your LLM should be remembering, or your agentic system or your system should be remembering what you talked to it 2 seconds back, right? And if you have a stateless system, it is impossible to do that. And that is why you require LLMs plus memory. Memory can be short-term memory, memory can be long-term memory. Long-term memory can be stored in persistent storage, for instance. LLMs plus memory plus tools, databases, etc. All of these are what makes an agentic system. Plus the workflow, everything together makes the system an agentic system. Okay. Just wanted to let you know. An LLM by itself will not be able to handle any back and forth conversation. And one more thing that I wanted to tell you is, for example, I was telling you in memory, there is short-term memory, long-term memory, etc., medium-term memory, etc. is there. So do you remember sometime back, there used to be a trend in Instagram, I think, where people used to ask ChatGPT to draw a caricature of themselves based on all the information that ChatGPT has about them. So you can ask ChatGPT to draw a caricature about yourself based on all the information that it has about yourself. And it was pretty accurate. So for someone who frequently travels, things about travels or flights were there. Someone who's an IT professional, your laptop, your usual app setup would be there, stuff like that. So people were surprised. And it was because based on the past conversation that you had with it, it profiled your, it user profiled you. It understood what kind of a user you are. It understood what you are. And in fact, since most of us ask a lot of personal questions to ChatGPT, it would even know how much you make, where you are, your personal struggles, your issues, even more than your partner. It might know. ChatGPT might know you better than that. So your memory can be short-term memory, which is the current conversation. Long-term memory, which is like building your persona, for instance. So your long-term memory can your ChatGPT might have stored it in a persistent device. Like for example, it might have stored in some of the data center somewhere. Your short-term memory would be ephemeral, mostly would be storing in memory, and then if it is not useful to be a part of the long-term memory, it would be wiped off at the end, so on and so forth. Just wanted to let you know. All right. Without going tangential, let's get back to identity verification and memory system. So the first thing is the identity gating. The identity gating means, see, whenever we start a conversation, the conversation is started at the verify info function here. Now, the verify info means you want to verify whether the customer's ID is already a part of this. Now, if the customer ID is already inside the state, from a prior conversation that we had. And then it passes through immediately. That means the customer is verified. This is the customer that is currently using it. Then you're good to go. Otherwise, the user is asked for the identifier, like for example, email, phone number, customer ID, whatever, however it is structured. And then it is validated, and only then the user is provided access to the rest of the steps. So the verify info node acts as an identity gating where it either checks for the previous states in order to identify the customer ID. Otherwise, it is going to trigger the customer ID requirement. Now, here in the identity gating, what happens is we use a structured LLM. And this structured LLM is used to extract an identifier from the user's message. And the LLM is expected to provide the identifier that it is extracted as a pydantic object. I'll explain all of this. Now, we are expecting the LLM to extract the user ID, right? So it cannot provide a free flowing text. It should extract either an identifier of the user, which is the user ID, or it should provide an empty string. Your step one would focus on, I think we had, yeah. All right. So your first step here. So your first step would focus on using the LLM in order to extract the identifier from the user's input. So in order to extract the identifier, you once again have a system prompt in order to tell how to extract the identifier, what an identifier looks like, and all of it. So from the user input, it extracts an identifier. And this identifier is extracted. And then this identifier is passed to a parser. And what happens here is this is validated. Now, this identifier can be something like your email, it can be your phone number, it can be your user ID, etc. Now, this identifier is extracted and passed to get customer ID from the identifier. Identifier, email ID, or whatever. So, but the only unique value that we require in order to fetch the past context, memory, everything is the user ID. And using the identifier, we pass it to the get customer ID from the identifier. And within that function, you have the logic in order to fetch the customer ID using the email and whatever, and the customer ID is retrieved. Now, okay. Now, within the get customer ID from identifier, there are some lookup strategies. Like, for example, that lookup strategy is not. Yeah. Certain lookup strategies. Like, for example, if it is a numeric string, then we perform a direct lookup with the customer ID. If it contains an @, then it is converted to a lowercase and we check for email address match. And then if it is not either of this, then it checks for it attempts to normalize by taking it as a phone number and attempting to normalize it and then comparing it with the phone number database. So in order to compare with the phone number database, it has to strip probably the international code, it has to convert it into a specific format and then perform the check. So that is what's happening here. Now, we did say that if customer ID is fetched, so this get customer ID from identifier is fetching the customer ID of, by using the phone number or email ID or whatever is passed inside. Now, once the customer ID is received, then it's fine. But if the customer ID is not found, what happens? It generates a response saying that if customer, this one. If it is none. So if it is none, it generates a response saying that, okay, we did not find the customer ID, so reattempt this process or enter it once again. So the same thing happens once again. But if the customer ID is found, then it simply returns the customer ID saying that this is the customer ID string and these are the past messages which are stored in the memory. Okay. All right. Just wanted to touch base on this aspect. All right. So we also discussed how the customer ID is looked up. We discussed how the identifier is extracted. So when we refer to an identifier, we are referring to any of these. Customer ID, email, phone number. Otherwise, it is going to trigger it once again asking for the identifier. All right, just wanted to mention this identity gating part. Okay. Now, coming to the human in the loop. Human in the loop is where the human provides an input. And at that time, LangGraph waits. And how does LangGraph wait? By using interrupt. We discussed this at the start. So the LangGraph interrupt pauses the graph at a node, saves the state to the checkpointer, and waits for external input from the user for resuming. Now, this is used when verification fails. That means from the previous context, if it was unable to fetch an identifier which was used to get the customer ID, then at that time it is going to ask for the customer ID, or it is going to wait for the customer ID by the user. And that is when the interrupt comes into the picture. The graph pauses until the user provides their credentials. So the sequence works like this. First, the verify info function that you had, we mentioned earlier. And if it cannot match the identifier for some reason, then it triggers should interrupt. Now, what happens here is it checks if is customer ID none. If it is yes, interrupt it and route it to human input. So after the verification is failed, which means is customer ID none? If yes, it goes for interruption and it triggers the human input. Otherwise, it continues the process. Now, once the interrupt is called, the graph pauses completely. The LangGraph is going to save the full graph state to the memory saver checkpoint. And then the Gradeo user detects this pause by checking the snapshot.next. Snapshot is what is currently happening. So snapshot.next is detecting the pause that is happening. Now, if yes, if the pause is detected, then it will wait for the user input. And once the user provides the input, the graph is going to resume. So it could either be customer ID, email, or phone number, and the same verify info is triggered once again, and then the verify info is triggered once again, and the graph resumes. So it's like a loop. So if the verification is failed for some reason, so I start a new session, and for some reason, based on the previous session, it couldn't fetch the customer ID, then it is going to trigger the verify info, and the verify info failed, and the interrupt triggered, and when the interrupt triggered, the UI is going to ask us the customer ID or the email or the phone number, based on which it is going to fetch the customer ID using the verify info. So this happens in a loop whenever required. All right. So this, even though it's called a human in the loop, it is not to train your model or to improve your model. It is just to provide a human input. So rather than human in the loop, I would call it human input. And in order to wait for the human input, the language. Now, the memory system. There are two layers of the memory system. And the first layer is called the memory saver, and another is called the in-memory store. Do you remember me talking about the ephemeral, short-term memory, and the long-lived memory or the persistent memory? Somewhat similar to this. So in this case, or in our use case, we have two kinds of memory. One is memory saver. And memory saver, the idea of memory saver is it is short-term, or it is conversation memory, because conversation memory need not be long-term. Why would you need the conversation memory from past session in the new session? There is no point in doing that. So it persists conversation messages within a session. And on the other hand, your preference memory consists of persistent requirements, like for example, your preferences, your interests, etc. And that is in memory store. So it is long term in nature and it persists the music preferences across sessions. So you told that you are interested in rock 2 days back. Today you're telling that you are interested in pop. And the long term memory would be feeding it in such a way that you're interested in rock as well as pop. Now, coming back to the conversation memory. The conversation memory is scoped by thread ID because I'm opening a new session. It's a blank slate. Now it enables multi-turn conversation because you have conversation memory. It remembers the previous conversation that you had, like 2 steps back. So this enables multi-turn conversations back and forth. So this enables your graph to reference earlier messages, and it is stored in memory only, very important. And it is cleared on server restart. Pretty much the same thing as your ChatGPT, Gemini, etc. You're going to start a new session, it will not remember. So consider this. I repeatedly tell ChatGPT that 1 plus 3 is equal to 5. Okay. Initially, it will not agree. Later on, it will agree. And I'll ask some questions based on that. And it is going to use the same understanding that 1 plus 3 equals 5. And that is conversation memory. Because the moment I start a new session and I ask what is 1 plus 3, it is going to say 4. Because that is what it was trained on. And 1 plus 3 equals 5 was a part of conversation memory. So it was not worth to save as long-term memory as well. But rather, if you say that you're a mathematician, you're an IT professional working on so and so stuff, buying a house here, so etc., that may be added to persistent memory or long-term memory, which can be used in future conversations in future sessions as well. So, which is why if two people are using the same Gemini or ChatGPT account, you can see some weird responses at times. So, me and my partner were using the same Gemini Pro account. So what happens is that the other day I was trying to compute some income tax related stuff on my payslip, and it made some assumptions based on my partner's pay because uh, both of us had used it for income related tasks earlier. So, which is why it can confuse the whole engine or the whole system, just letting you know. Just like how two people using Spotify can screw up the recommendation system because one person's preference would be something else, and the other person's preference would be something totally else. So, just letting you know. Okay, coming back. So, your conversation memory is there, your preference memory is there. Now, your conversation memory is in memory, ephemeral, and it is not persistent, and it will be cleared on any new session. Now, okay, wait. Okay, now the for some reason it's this mode away. Okay, yeah, it was here, right? Okay, perfect. Okay, so what were we referring to? We were referring to the memory store. Okay, coming back. So in the long-term memory store, we have a memory profile for each customer ID and one namespace per verified customer. So if you did not authenticate yourself with the customer ID, then whatever you say will not be stored into the long-term memory because it is associated with a customer ID. Now, the key that we will be using is the user memory and the value will be the user profile object. Now, if you are interested to go into more detail into it, you can try reading about something called Pydantic. So Pydantic is a library which we usually use for data validation purposes and to ensure that the data is in a specific format, for instance. And the user profile here is actually a Pydantic object with a list of preferences, just letting you know. So you can try reading about it if you're interested in it. Otherwise, keep it aside. Just consider it as a list of preferences for a particular user per customer ID. That's it. Now, your browsing history is not saved. Your past questions are not saved. Only explicit preferences are saved. Example, rock genre. If you explicitly tell the chatbot that you are interested in rock genre, it's going to save it. But if you perform 100 searches on rock music, it is not going to save it. That is how we created it. But if you want, you can create it in such a way that you are going to use your browsing history as well to keep updating your long-term memory. All right. So it's totally up to you how you want to do it. So in this scenario, we used only explicit preferences. And new preferences, when they come in, the existing ones are not removed. So tomorrow, if you say that you're interested in pop, it's now rock and pop that you're interested in. So you can also consider probably removing interest n number of days back or something as per your logic. Now, In production systems, we generally replace this in-memory store with something very quick, like Redis, for instance. And for memory saver, for conversation memory, we use something like Postgre saver or SQLite saver in order for quicker retrieval. So in day 2, we'll be covering that, don't worry. So this is just the current setup, which can be productionized, obviously, but it will not be scalable for a lot of users because there would be limitations with respect to the memory growth, with respect to the fetching, etc. Just letting you know. Now, the pydantic models. I was telling you why pydantic is used. Pydantic is used in order to structure your LLM's output, or in order to verify whether the outputs are in a preferred structured format. Now, we already discussed that user input is verified by the verify info function. And the LLM is forced to return exactly one identifier field, which is your customer ID. And the default is empty string. Sorry, the LLM is expected to return one identifier, which is your email ID or phone number or your customer ID. Just one. Now, and if none is found, the LLM is going to return saying that it could not find the identifier, something like that, right? This one. Where was it? Return customer ID, else this one. Yes. So if no elements, or what do you call that, credentials, if no credential was found in the text, then it is going to say that it is going to return a string saying that it was not found. It is not going to return an empty list or anything. Now, that was your verify info function. So the default is, so it is going to return a string and it is not going to return an empty list or anything. So there is no scope for hallucination here because we have kind of used a function in order to make it do it without by explicitly asking it to focus on these things. So either one identifier or a string. That is what we asked it to do. Now, similarly, the user profile. So in the create memory function, we use user profile in the create memory function. So the LLM creates explicit music preferences from the conversation if the conversation explicitly mentions that. And if yes, it merges that with the existing profile. Now, there is a function called with structured output. And the idea is that this is the LangChain method that forces the LLM to respond using a JSON. JSON would be a set of key value pairs, saying that something like, where did we see that? In a JSON format, we saw it somewhere earlier, right? I thought we saw it. Okay, it's fine, ignore it. So one example of JSON could be something like if you're fetching we are talking about LLMs, right? So if you want to trigger, um, a mix of invoice with respect to the customer ID, a function with invoice and customer ID, then the LLM should be fetching from the user's input as to what the invoice number is and also what the customer ID is. Customer ID is not injected via LLM, but rather customer ID is fetched from the context, like we discussed earlier. So the idea is that the input to that tool should be created by the LLM in such a way that the input is a JSON format with proper key value pairs. And that is the with structured output function, which is a LangChain function, ensuring that the output from the LLM is in the required format. For example, the JSON format that you wanted it to produce output as. Now, I just wanted to mention these aspects. Okay, so the pydantic schema. There are certain schemas where we tell the LLM exactly how to return the data, and it is going to ensure that that kind of data is being returned. And we use pydantic in order to validate that as well. So it is not simple regex parsing, but rather we will be guaranteeing a structured output using pydantic. So pydantic is a data validation library. By the way, these days there is something called pydantic AI. Pydantic can be used to build multi-agent systems. If you want, you can go into that. You can try reading about that. But classically, pydantic is used for data validation purposes. And it's a data validation library as well. Okay. Now, coming to prompt engineering. So I did tell you that each of the agents that we had prompts underneath them, which is called the system prompt. So you have to engineer the system prompt pretty well in order to ensure that it behaves the way that you are anticipating it to. And also, you have to ensure that there is proper grounding. Grounding means it doesn't hallucinate based on the data that the LLM was trained with. So prompt engineering and anti-hallucination is what we'll be discussing right now. First thing, anti-hallucination, whenever we talk about that, we'll be talking about grounding. Grounding means ensuring that the response is based only on the data given or only on the data that it has access to on our data. Because the LLMs would be trained by and the LLMs would know a lot of music, would know the information about a lot of music, etc. But if it starts to give out all of that, then it won't be using our database. But we have to ensure that it uses our database, and that is why we have to use grounding. All right. Now, hallucination is scenarios where the LLM hallucinates or LLM produces incorrect responses, even though it might sound right. So this used to be a predominant scenario with the earlier variants of ChatGPT, but these days things are much better. But we want to try to ground it to ensure that it does not hallucinate. Now, instances of hallucinations could be, so in our database, we would be selling certain songs for or certain albums for so much of price. But LLMs were trained on huge corpuses of data. And if it starts hallucinating, it might produce the price in some other website, not in real time, but on the data that it was trained for. So we don't want any issues like that, because if you ask whether it is incorrect, it's not incorrect, but it is not relevant to what we want. So that is hallucination. All right. Or it can pull up invoice numbers from some other data set that it was trained with, etc. Now, in order to mitigate this, we have 6 rules for grounding. And the first rule is tool-only responses. That means only provide the information given by the tools. Never infer, make changes, or extrapolate the information given by the tools. So that is the first method of grounding that we are using. We already discussed multiple tools, around 9 tools that were used in both of the subagents, right? So all of these are to ensure that it responds only based on the data that we have. Exact quoting. So quote the exact numbers from the tool results. Never round it, never approximate it, never estimate it. So $8.91 stays $8.91. Now the honest failures. So if a tool returns empty results for some reason, then it should say that I could not find it in the catalog. Never fabricate any alternative. Never attempting to return empty results are fine, but still the LLM is expected to produce output in the form of string. So if so, let's keep it no results rather than an empty string. That is why in almost all the functions that you came across, there was a strategy where if the actual results were empty, replace it with a string saying empty and then give it back. Now, the scope boundaries. So if a query is outside what the tools can answer, then explicitly say that. And don't try to answer from LLM's training data. That is the scope boundary. So we are trying to tie it down to the tools or the functions that we have as much as possible and attempting to mitigate any possible hallucination or any possible self-answering by the LLM. Now, no memory-based answers. So the idea is that always call a tool before answering. We have ensured that the workflow is in such a form that always a tool is called before answering, and never answer from the LLM's training data about anything that it already knows. Now, the truncation transparency. So whenever you're producing responses like the top 10, top 20, etc., you have to explicitly say that these are the top 20 so that the user knows that more of them exist. Like, for example, here, I had asked, what are the rock songs you have? It gave me a few rock songs, and then it said that there are a total of 1,309 rock tracks in our catalog. If you need more information, do let us know. Okay. By the way, what you're looking at is a deployed variant of the customer service chatbot, which we are deployed it in something called Hugging Face Spaces. So if you're interested in knowing about that, it's called Hugging Face Spaces. I think in tomorrow's session, we'll be covering that. So Hugging Face Spaces can be used to, used to deploy your models, and then anybody can use it. Okay, and this is the local deployment. You can see here, there is a local deployment as well as a Hugging Face deployment here. You can see both of them. And the instructions on how to deploy them, once again, complete list of instructions on how to deploy them locally. One moment. The local deployment instructions were here, and the Hugging Face deployment instructions were here. Okay. Now let's get back. So we were talking about truncation transparency. Whenever there is truncation, explicitly say that there was truncation. That's it. So these are the grounding rules that we use to ensure that it does not hallucinate. It attempts to produce the best responses that it can, and all of this. Now, the music agent prompt. So the music agent prompt is dynamically generated at runtime. So we will tell you, the idea is that we'll walk you through how this is generated. So this is generated using an F string. We'll talk about how it works. So one moment. Music generator. Yeah, here. Just wanted to cover this aspect. So you can see here that there are 4 design patterns. And the 4 design patterns here are, one moment, here. One is the F string injection. The idea of F string injection is that, see, your memory is loaded from the in-memory store, and it is injected during the time of call. So your memory is fetched from the in-memory store, and it is injected during the time of call. Now, every request is going to get a personalized prompt. And the customers, for example, the customers who like rock get something like prior preferences as rock, AC/DC, jazz, etc. So depending on the user query, every request is going to get a personalized prompt, and that is created using the memory. So the LLM looks into the memory, understands what the memory has, and creates this personalized prompt. That is in the green. The preferences, rock, AC/DC, etc. Now, there is something called section headers, and you can see the section headers here. These ones are the section headers. And these section headers are responsible for formatting, or this format is responsible for delineating the different rules, the different tools, the different guidelines, etc. And the LLM hence will understand. This is like structuring paragraphs or structuring titles. The LLMs will understand that, okay, one block of text like this refers to grounding rules. This block of text refers to the tools available. This block refers to the search guidelines, etc. So that is the section headers. And then you have numbered rules. Each rule is separated by a number in order to show that they are different rules. Now, the LLMs follow the ordered lists better than a whole paragraph. So if you give a whole paragraph, the problem is the LLMs are fine with following paragraphs, but the performance would be much poorer than giving serial numbers and giving an ordered list. So which is why we adapted to this. And LLMs work better if the input is structured very well. And you can see that the input is structured very well by separating them into sections using the section headers. Now, we did discuss numbered rules, and the last one, the tool list in the prompt. You can see here, all of the tools available are listed in the prompt. So why we call this an F string injection is because where have you seen F? So Python programs, one moment, I'll just show you a very simple F string. So in case you are not aware of it. So if I give a variable name, okay, name person equal to Justin. And if I say printf name person is taking the session, it was using brackets, right? Let me see if that syntax was right. Yeah, perfect. So this is the F string that I was talking about. We need to give something like F to say that there is a variable in the string, and that variable in the string is given as given in the curly brackets, and the name of the variable is given here. The same methodology is used here. So here you can see this is here, and this is a whole string, and we are returning the whole string. And this whole string is a generate music in music assistant prompt. This is the system prompt, and it takes in memory as an input. And from the memory, using the memory, it returns this. Now, this string is already structured and formatted. But the interesting thing is a few things. If one variable is there, and that variable is here, see, prior saved user preference, that variable is given directly to the LLM. So why we created this as an F string is because we wanted to add a variable into the string, and that variable is the memory here. So F string injection simply means a string where you have a variable. And in this particular use case, we used memory as the variable. That's it. Just wanted to show this. And you can see that it is not just a string with the memory, but a lot of other instructions around that. Providing the grounding rules, providing the tools, providing the role as to the fact that you are a music catalog assistant, providing the tools and the search guidelines. So just wanted to showcase how the music agent prompt is structured. So you can see that you will see when you build agentic systems, you will see that system prompts are used everywhere. And for different system prompts, you would use different variables as well. Okay. Now, yeah, just wanted to touch base on this. So we had the tools available, we had the grounding rules, we had the role as well. Now, the idea is that this prompt is rebuilt on every single request. So this part remains exactly the same, but the memory part is dynamic. So for every single request that is coming into the music agent, the system prompt is slightly different every single time, depending on how the memory is structured or what the values the memory contains. Now, the end-to-end request lifecycle. So now we discussed all of the individual components. Now it's time to trace a complete request from the moment the user presses enter or presses send to the moment they see a response. What happens underneath? There are a total of 9 steps. We'll discuss that. So this was the request lifecycle, the different steps of that. So the step 1. Sorry. Let's start with step number 1. Step number 1, the user types a message in the Grad.io UI. Something like this. For instance, all of these are my messages, by the way. So I just wanted to show you grounding. That's why I just asked this. And Thriller, the song Thriller from 1992. I don't know whether it's an album or a song. I think it's a song. So from 1992, it searched the music catalog. It couldn't find it. Just that it did not have it in the music catalog. So like I said, irrespective of how famous the song is, it should not be fetched if that is not there in the music catalog of our inventory. Now, similarly, I had asked for suggestions as well on rock songs, and it triggered the correct agent, and it got me what I wanted. Now, coming back, this is the Grad.io UI, and this is where the user types in the query, and this is how the user sends the query, just like a regular chatbot. Now, when a user sends the query, the show user message function appends it to the chat history, and the status will show us processing. So the show user message takes the user's query, appends it, and the status is shown as processing. Now, a new session is triggered. So a thread ID is generated for that. Now, it scopes the memory saver to exactly this conversation. So there is a new thread created, and for this thread, you have memory saver scoped for this. Now, the human message is created already. The graph.stream is called with the message. So the graph.stream is called with the message and the thread ID. So 2 things are passed, message and the thread ID. And the graph starts streaming the node outputs. Now, The next step is that I know it might be a little complex, but we are going a bit deeper into the land graph architecture. That's why you're seeing multiple aspects like uh, your graph stream, etc. So if you're interested, you can go more into the details of what graph.stream is. How does it work? What does it do, etc. So I just wanted to give you a high level idea into the life cycle, which is why I'm going into this. That's it. So the graph enters the verify info function. So we already discussed what the verify info node is. So this is what checks the customer ID. And if the customer ID is already available in the context, then it passes through. And if it is not available, then a re-verification is needed. And if a re-verification is needed, the human should be providing the verification at that time. It is going to interrupt. We discussed all of that earlier. So if verified, it passes through. Now, step number 5. An ID is fetched, right? Either from the previous conversation or based on what the user has provided. Now, if there is no ID in the state, in step number 5, the structured LLM is going to extract the identifier. So the user input plus the extraction prompt gives the identifier. Identifier can be your email, can be your phone number, can be your customer ID, etc. So that is the case where no ID is there in the state. When no ID inside the state, then step number 5 happens. Now, coming to the database lookup, which is step number 6. Here, it extracts the identifier. Because earlier we used, it extracts the ID. So earlier it extracted the identifier, which is your email ID or phone number or whatever. Step number 6 figures out the ID. So it gets the customer ID from the identifier. Like for example, if it is phone number, it unified it and then it performed the search and fetched the ID. Then if it is email, it converted to lowercase, identified that, converted to lowercase, and then used the email from the search. And if it is a number given, it directly looks for that ID value directly from the table. So that's what happens in step number 6. So one moment. Yeah, that's what happens in step number 6. And in step number 7, the load memory runs. What load memory works is that, see, the memory profile has to be loaded. And that is where you get the preferences like rock, ACDC, etc. Now, either the memory is retrieved or if the memory is empty, it is going to return an empty string, not an empty list, not a different data type, an empty string. Now, the memory is required for what purpose? Memory is definitely required for purposes like this, for instance. So where we plugged in the memory here, if you remember. Now, coming back. In step number 7, we discussed the load memory. So the load memory is complete. The memory is loaded, either the memory or the empty string. Now, step number 8. This is where the supervisor comes into the picture. The supervisor takes the query, passes to the LLM along with the supervisor prompt. Supervisor prompt plus the user query is passed to the LLM. And the LLM decides which subagent to be triggered. Should it call music catalog or should it call invoice subagent? Now, once that decision is made, the reasoning plus action subagent loop executes. For example, if it is the music catalog subagent, then we had discussed the detailed steps of how that works earlier, right? All those steps will be triggered. So first, the reasoning would happen. As to that, there are like 4 or 5 tools available for the music catalog agent. Then, out of these tools, which tool should be triggered? And the tool will be called. The response from the tool is brought back, and then the agentic system, the LLM, checks if the response of the tool is sufficient to produce a response for the user. And if no, this process is continued. Like, for example, a different tool is to called if required. All of these is done repeatedly until it gets the final answer. So the LLM is what validates whether the answer is satisfactory. Satisfactory means whether we have a proper comprehensive answer based on the user's question, or should additional tools be triggered. LLM is the brain. That is what makes this decision in the reasoning plus action. So reasoning is done by the LLM. Now, after the reasoning plus action loop, where the answer is satisfactory, then what happens is the answer is given back. So the answer is given back to the user once the answer is finalized, and the memory is updated. If any updates to the memory are to be made, that is also updated. And this is the memory updation that we were referring to, and the answer is given to the user. So this is what happens in the request lifecycle in the 9 steps. So you can see that your agents started triggering only by step number 8. Until step number 8, it was all the verification, the pre-processing, and everything that were happening. Just letting you know. So which is why I was explicitly saying that LLM is just one part of your agentic system, which is used in multiple aspects within the agent, fair, but LLM is just one aspect. Okay. Now, the Grad.io UI. So the Grad.io UI actually uses a two-phase event chain. The idea is that Grad.io is a Python package that we use to develop user interface. And it is very user-friendly, very easy to generate. And in fact, you can just ask ChatGPT to generate a Grad.io UI, and it is going to create one for you and provide you the code, probably 10, 20 lines of code, and you can run it. Now, the idea of Grad.io is that it uses two-phase events. And I'll tell you what two-phase events are. So first, there is phase 1. And in phase 1, what happens is the user's message is going to appear in the chat. And the input is cleared and the status changes to processing. So the user message comes in. Once you click the send, the user message goes in, the input area is cleared. And then the status changes to processing. And the user will see the message immediately. Now, phase 2 is the complex part, because phase 1 is the easy part to clear everything and to create the processing part. That's the easy part. And phase 2 is the heavy work. And inside phase 2, it's asynchronous in nature. And inside phase 2, what happens is something called graph.stream runs. The idea is that the LLM calls, why is the quality a bit low here? One moment. Yeah. In phase 2, you have the graph.stream. So what happens here is the LLM calls happen. The tools are executed. And this takes a few seconds in order to get everything running, probably 2 to 5 seconds, because we are having our entire database in our memory. So it's fine. So all of what we discussed earlier, the LLMs, all of these things, the agents, the sub-agents, all of these happens in phase 2. Now, after the phase 2, we check snapshot.next. Now, if the graph is so if it is truth, then so what happens is, see here, we are going to interrupt it. Now, the idea is that, see, after we produce the output back, we have to check whether there is a new input or not. If there is no new input, we are going to interrupt it. And now we are going to wait for the user's input. Now, if there is no user input, we just continue the process. That's it. So the idea is that each thread is isolated and each thread does this end to end. So you have initially the message given by the user, you have the input that is cleared, and you give the status processing, and then everything underneath, under the hood, all of the agents, all of the sub agents, and all of these are triggered, and your complete output is the complete LLM work happens under the hood. And after that, it decides to respond. Either it responds and says that it responded in 2.1 seconds, something like this. It provided a response and it said that it responded in 4.1 seconds. Or it provided a response and it says that it responded in 17 seconds because the query had a lot of things to fetch. So this is the scenario that you see on the left. The scenario that you see on the right is waiting for another input by the user. So if there are any additional inputs required by the user, then the final response should not be provided, but rather it should take the right side path, which is waiting for additional input by the user. Probably, consider this, I'm asking for a specific invoice. And if the specific invoice is asked for, and the LLM understands that, okay, LLM fetched the responses corresponding to it, but for some reason it should not give it because the user ID is not verified. In such a scenario, it should go to this path where it says waiting for user input, and it should ask the user as to what your customer ID or any other identifier is. And then it should wait. In other words, it should trigger the interrupt. So interrupt trigger is triggered only when we are waiting for some input from the user's end. And if there is no interrupt required, it can just provide the response, and it could change the state to responded in so and so seconds. Done. So this is how the Gradeo UI works on a very high level. Just wanted to mention that as well. Yep. So this was our last part, which was the Gradeo UI working. And with respect to interview preparation, so how much time do we have left? We have around 5 minutes, right? So yeah, with respect to the interview prep, yeah, there would be questions like, one popular question would be, why use a multi-agent architecture instead of one large agent? So we already discussed that at the start of the session. The primary responses should be focusing on the separation of concerns. That means if you have a single agent, then it should have access to all of the tools. It should have access to all of the tools, all of the databases and everything. The chances of an incorrect tool being called, the chances of an incorrect database being fetched is much higher if there is one agent having access to everything. But rather, if you have a separation of concern, or if you have modularized it using multiple agents, then the chances of it fetching a better response is higher. Now, managing prompts. So having a big prompt mentioning every requirement, demarcating it, might affect the quality of performance of the LLM. Because one, the context limit is there. Ignore the context limit. Even then, you might have observed that when you have very, very long prompts compared to concise prompts mentioning what you're expected to do, you might have noticed that even your ChatGPT or all of them might tend to skip some information in the very long prompt. So that is also a problem with a single agent system. So if you can have multi-agent systems, you can have different system prompts, sorting the issue. Then the tool isolation. So if you have 9 tools, all the 9 tools need not be shown to the one agent. 5 tools might be useful for something. 4 tools might be useful for some other thing. So why don't you just show those tools only to the agent that requires to use those tools in the first place? And then independent scalability. So your music catalog could be queried a lot more times. That means, see, if you want to query the music catalog more compared to the invoice, then you can do that as well because it is separated well, so that you don't need to trigger the same heavy single agent again and again. So you can scale your music agent a lot compared to the invoice agent because the music agent can have more pods or more requirements or more hardware because it is required more. So rather than having a single agent, this can also help. Now, coming to the testability aspect, you can test each module separately, which is how just like your modularized systems in software engineering, you prefer to use multi-agent systems if there is a separation of concerns. If there is a separation of concerns. All right. And the next question could be, how does the system prevent Oh, wait, one moment. Yeah. Yeah. I think I missed this. One moment. Yeah, there could be another question asking for how does the system prevent hallucination? So if the question is about hallucination, yeah, if the question is about hallucination, then you can clearly say that grounding prompts were there, the tool enforced data access was there, then you had other methods like exact number quoting, you had the parameterized SQL, then you had failure instructions. That means if you have empty results, it did not provide the empty JSON or the empty list, but rather provided an empty string or a detailed string as to the fact that there were no responses. So all of those that we discussed a bit earlier, that corresponds to ensuring grounding or preventing hallucination. Okay, then we discussed that. Yeah, how does LangGraph's shared state enable multi-agent coordination? So this would require you to go a bit more deep dive into the LangGraph architecture, but still, you can say that there is a single source of truth for all the nodes, like whether it is verify info, whether it is to load the memory, whether it is the supervisor or the sub agents, etc. All of these reads and writes to the same state object, which we had discussed at the start. Now, you don't have different state objects, so that the shared state is going to have a consistent single source of truth, ensuring that there is no data inconsistency. Now, there is also something called add messages. If you remember, if new messages comes into the picture, like for example, the person prefers pop songs as well as rock songs. Now, the pop genre is a new addition. In that case, they are appended to the list and they are not replaced. Now, the good thing is that any replacement, the appending ensures that the past information is also retained. Now, the customer ID propagation. So the customer ID is not taken from the user's text directly, but rather based on the state. So like we already discussed, the customer ID is verified once. After that, based on the state, the customer ID is fetched, not by what the user can provide. So ensuring that this is an added layer of safety so that I cannot look up your invoices and vice versa. Now, the loaded memory injection. So the load memory writes the preference as a string to the state. So the music assistant is going to read the loaded memory and injects this as a string once again to its system prompt, if you remember this one here. So since it's a string, it is able to ensure that you don't need to make any changes to it in order to inject it to the LLM. So everything is smooth. So there are a lot more aspects that you can possibly discuss about LangChain's multi-agent coordination by discussing about the inbuilt functions of LangChain that we have used, but not going into that in the interest of time for now. All right. So, good. So there are a lot more aspects that we have to discuss, like what exactly are the details of the code? How do we handle the error? How do we observe this run? How do we productionize the system? All of this, which we'll cover tomorrow. And if you want to run it, meanwhile, if you want to run it, the detailed instructions on how to run this is given in the README file here. So let me share this once again with you in the chat. Here you go. All right, so I see a few questions in the Q&A, and I hope our TA was able to answer your questions. Oh, 240 questions were answered. Thank you very much, Abhinav. Yeah, for taking care of it. Yes.
Yes, amazing session, Justin. I mean,
Thank
there
you.
are 240 questions. Like, props to Abhinav also for taking all of them through. And I was just checking with Claude as well. All the chat questions have nearly been answered. We have picked it up in a session. So I think we don't need to have a separate Q&A session today as such. That said, I also noticed that a lot of people have been asking for recordings and notebooks and everything. What we've done is we have equipped the, say, PA, the program advisors, with the resources that you might need, the recording of the session or even the PPT that we've also seen a lot of people asking for the presentation that we've used. So if you're able, you can still see the poll on your screen. If you're able to answer on that poll, the program advisors will be reaching out to you over the week. So then you would actually be able to get the resources that you're looking for there. Otherwise, if you wait long enough, I think this also comes up on our YouTube channel. So that's the way you can get the recording. On that note, I'm going to end the second poll right now. And as part of feedback session, because we do it as an iterative process, right? We keep doing this again and again. So hopefully the next time can be even more optimized so that all of our times can be well served. So on that note, I'm launching one more poll. So give us our feedback and see you guys tomorrow. Same time, same slot, same instructor also. I think Justin would be closing loop on even further things. And great having all of you here. Is there any final questions out here? We would wait here on the chat for like another couple of minutes so that if any final queries are there that can be solved for. Appreciate you all taking out your weekend time for doing this with us. Thanks a lot. And crazy level of thanks to
Thanks,
Justin.
everybody.
You for taking time.
Thanks, everybody, for joining in. Thanks for all the questions. And I've shared an additional link in the chat as well. If you're interested, you can take a look at this. Yeah. Thank you. Have a great day. Bye-bye.
Thanks, everyone.